each one of you here in this room to immerse yourselves in the experience, to engage, to connect, and to get inspired. May our time together be filled with discovery and boundless spirit of collaborations. Welcome to 2024 COMPUTEX Forum. Thank you.
Thank you, Simon, for the warm and exciting remarks. Now, let us dive into our innovative journey by welcoming the first speaker of the COMPUTEX Forum, Mr. Mark Hamilton, Vice President of Solutions Architecture and Engineering at Nvidia. He will share how Nvidia specialists help you get started with Gen AI at any scale. Welcome, Mr. Hamilton.
Welcome, everyone. It's my great privilege to be kicking off the COMPUTEX Forum this morning. Last week, one of my engineers was showing me a computer-generated, a AI-generated news post on a social media site, and it said, Mark Hamilton, the famous actor, will be kicking off COMPUTEX Forum talking about AI. And the post went on to say even what movies I had starred in. I can assure you, I am not a famous actor. I actually work for Nvidia, and I help our customers and our partners build the AI factories that Jensen has been talking about. Those of you who know Nvidia and know Nvidia culture will know that we like to do. We don't like to talk. And so we talk quickly and we talk concisely, and we explain in simple terms what we do. So one day, several months ago, Jensen wrote a very short email, and he said, Mark, what your team does is IBTG, Infra, Build, Train, Go. IBTG, and we use this now at Nvidia. An AI factory is about the infrastructure. The infrastructure is, of course, not just many boxes of GPUs. The infrastructure has to be built. We need all of our ecosystem partners to help us build that infrastructure, and then it needs to be assembled into an AI factory. And why? As soon as you assemble it, you want to start training models, and after you train the models, you go. You run the models. You run your business. You start making money. So let's go ahead and get started, and I'll talk a little bit about how my team works with our partners, works with the ecosystem to help IBTG. These observations are not from PowerPoint slides or studies. This comes from installing hundreds of thousands of GPUs in AI factories. Our first AI factory at Nvidia was built 8 years ago, 2016. My team and other engineers at Nvidia started to build our first AI factory. We had just introduced at COMPUTEX the P100, the Nvidia P100 GPU. I'll show some compares of how we've gone in 8 years. But we've also learned many, many things in those 8 years about installing these systems. An AI factory is not regular data center or regular cloud. It is AI computing. And AI computing is not just about the GPU or adding the GPU to the server. An AI factory is an end-to-end solution. It is nearly impossible to simply build one part of the factory. If you only build a GPU, if you only build some software, if you only build part of the network, it's impossible to think through how you optimize from end to end. And it is, in fact, because Nvidia, for 8 years, has been building our own AI factories for our engineers to use. If you listen to the keynote or read it all about Nvidia, you know how we don't just sell AI factory, we don't just build AI factory, but we use AI factory. We build robotic software, we build AI software for autonomous vehicles, we build AI into our platforms for PC gaming and computer gaming that so many enthusiasts across Taipei, across Taiwan love. What are some of the lessons? How do I measure my team when they build hundreds of thousands of GPUs into hundreds of AI factories? We've actually come up with 3 very simple metrics. This is one of the things I love about Nvidia. We take something very complicated, building the world's most complex AI factory to train Llama 3, Mistral, other leading open source models, and we condense or summarize into 3 things. The first, and I measure this for every AI factory I build, is time to first train. Because if you're lucky enough to receive 1,000 or 10,000 GPUs, be it an end user, a cloud provider, another partner, you want to be able to quickly as possible start training your models. You want to train your model so that you can be ahead of your competition, so that you can use the model to start running your business. Traditional supercomputers have often taken 6 months, 12 months, 18 months to set up. There has been for many decades a list of the world's top 500 fastest supercomputers. And many of these, of course, can run AI today if they are accelerated and be used. But these supercomputers were built by large national labs, by large universities, where they had many PhD students, many researchers that had their job was to build supercomputers. As AI factories move into the cloud, move into regular enterprises, we can't build every one of them differently, like the top 500 supercomputers. We need a recipe so that we can deploy them quickly. The GPU is simply too precious a resource to be deployed and sit in your data center while you try to assemble it. So time to first train. AI supercomputers actually are very good at traditional science as well. In fact, many of them end up being put on the top 500 supercomputer list. There's a pharmaceutical company in the United States, Recursion Pharmaceutical, and several months ago, they ordered one of our DGX SuperPod AI factories, and they waited a little bit too long. And so they were going to miss the deadline for the top 500 list in June. So they came to us and said, how quickly can you install it? It was 512 GPUs, relatively small by the scale of systems today, but still relatively complex. That many GPUs, you might take months traditionally to set up. And the top 500 deadline, by the time they received their systems, was 1 week away, 5 days away. We were able to install their system in 1 week, run the top 500 benchmark, and get it on the top 50 of the top 500 supercomputers. And it's there today. You can go look at top500.org and see Recursion Pharmaceutical. So time to first train. Second is GPU availability. Now you might say this is a funny metric. 100% of the GPUs should be available. Now remember, Jensen talked about our latest GPU, the GB200 NVLink 72. One rack, 600,000 components in that rack. And now many of those racks, millions of components in an AI factory. If you wait for every single one of those millions of components to be perfectly running, you will always be waiting. The software working together with the hardware has to work around failures in the system, be resilient to failures, and continue to train the model. Because these large models, a trillion parameter model, may use tens of thousands of GPUs, many racks of GB200 for many weeks, maybe many months. Impossible to keep all the equipment going. So what is your availability at the time to first train? And finally, what is the time to train? To measure how good a job we did putting together the cluster and measure how good a job the OEM and our other partners did to make sure they followed our recipe, we compare against our internal supercomputer that is our reference. And I'll talk about some of our internal supercomputers. We get a time to train. We run this test for about 6 hours. It can be run shorter or longer, depending on your needs. The test runs Nvidia's own Megatron open source LLM. Many people have maybe never heard about Megatron. Certainly not as common as GPT or Llama or even Mistral, some of the other models. But because Megatron is open source, it's an open reference. Any OEM, any customer can get that benchmark, run it on their system, run it on their cloud, and compare how good it is. And so for 250,000 GPUs that my team installs every few months, simply 3 numbers: time to first train, GPU availability, and time to train. And with those 3 numbers, which we know for every size cluster, 1,000, 10,000, 20,000, and for every OEM, we can compare and judge how well we're doing. And why is that so important? It's of course so important because of the advances in generative AI that you're all hearing about. Now, ChatGPT did a great thing. Nvidia and many other companies had of course been working on generative AI for many years. But it was researchers, it was in the lab, maybe some data scientists. The average CEO, the children and the parents of the average CEO had never heard of generative AI and large language models. And then in November of 2022, OpenAI released ChatGPT. And now not only every CEO, but the CEO's children or grandchildren and parents or grandparents for the younger CEOs, all of a sudden could see the power of Gen AI. But of course, and it's funny to talk about ChatGPT as that early or first generation of generative AI, was relatively simple compared to what's being done today. It was simply text, chat. Type in, type a few hundred words, get a few thousand words back. But now think about all the ways that we're learning to use generative AI. Generative AI is, of course, multimodal. It could be text in, it could be audio in, it could be an image in any of those out. Think 100 words in, many images out. 100 words in, a multi-gigabyte video out. And then as Gen AI applications are connected together with agents, you have one Gen AI application calling another, and interacting, and then bringing you back a story, operating a robot in a factory, showing a car how to drive down the street, automating many other tasks. So how does NVIDIA help customers move forward and get started? Beyond simply building Gen AI factories. If we were to come in and build a Gen AI factory, or if you were to rent a Gen AI factory from your favorite cloud provider, and all of the cloud providers work with NVIDIA and follow our blueprint for putting together these Gen AI factories, then what do you do with it? Well, NVIDIA Inference Microservices, or NIMs, a very short word, easy to pronounce, N-I-M, NIM. What is a NIM? Well, the challenge with the good thing about Gen AI is that so much of it is done in the open source. You have, of course, proprietary models owned by companies. Not that proprietary is bad. Gen AI or ChatGPT, Gemini, other proprietary models. And then you have fully open source models. In the open source community, everyone can see, as the code develops, as the models are released, can take advantage of those improvements in the model, and other researchers can improve on top of that. And of course, companies will continue to develop their own models, proprietary, and then when they're ready, release amazing new features for you to use and through APIs for their partners to use. But as a data scientist, as a developer in an enterprise, how do you get started with Gen AI, with all these open source models? A very good analogy is perhaps 20 years ago in the early days of Linux. Linux has, of course, open source versions. The fact that the Linux kernel is open means that different companies around the world can go in and build Linux operating systems, add their value, and distribute them. Red Hat Enterprise Linux, perhaps one of the best known enterprise distributions of Linux. And so what NVIDIA felt the world needed was not another Gen AI model. NVIDIA, of course, has our own models under the Megatron name. Some are closed, some are open. There's great models out today, and there's many open source models. So we'll continue to develop our models when there's a need. But the open source models are so good, but we needed an operating system for AI. Just like as an enterprise, when you started using Linux, you went to an operating system provider to get an enterprise copy of Linux. Where does an enterprise go to get an enterprise copy of everything you need to build and to run AI? So that is NVIDIA AI Enterprise, our AI operating system, and our NVIDIA Inference Microservices. A microservice is, of course, means that you do not need to install the entire operating system. You can install the entire operating system in your data center and run a microservice on top of it using our APIs, or you can simply call an NVIDIA Inference Microservice that is running in any of the clouds. So again, what then, besides, what is at the core of an NVIDIA Inference Microservice? We take all of the leading open source models, Llama 3, Mistral, on, our own models, and we optimize them for our GPUs. Not just for one GPU, but for all of our GPUs. The A100, which is still in many clouds, the H100 and the B100, and of course, thinking today about how do we optimize models in the future for our new Vera Rubin GPUs coming out in 2026. Only Nvidia could be thinking today about how we optimize AI software for a chip that is not even built yet. So what's the result when we put the two of these together? These are some of the internal supercomputers that Nvidia has built. I mentioned that our first supercomputer was built back in 2016. It was called Saturn V. At the time, like the Saturn V rocket from NASA, we thought it was a very big supercomputer. It turned out being the 30th fastest supercomputer in the top 500 list at the time. There was no measure back in 2016 of how fast an AI factory or AI supercomputer is. Today, of course, there's the MLPerf set of benchmarks. And these supercomputers that you see here have been year after year #1 in performance on MLPerf. And in a sense, that's not very surprising. Nvidia builds the chips. We build much of the software that's inside the large language model. We build entire supercomputers. So of course it makes sense that we should be able to optimize and be among the fastest in the world. So our new super chip is called Blackwell, and we've heard a lot about it in the last several months, so I won't go and repeat too much here. But again, it includes many components built by our partners. The chip itself is, of course, fabricated by TSMC. We work very closely with TSMC on the 4N process for the transistors. And again, as great as TSMC is, we take all of their tools, all of their knowledge. Our engineers sit together here in Taiwan and across the world, and we figure out how to make the process even better for Blackwell in future chips. It uses fast HBM memory from the 3 leading HBM memory providers. I believe Micron is talking later today, which is one of our partners for HBM. And what's the result when we put Blackwell together with all of our experience building AI factories? Well, again, this is looking at it in several different levels. And the first is you'll say, well, Mark, you know, NVIDIA's chips keep on getting more expensive. And that's true if you look at the price of an individual chip. In fact, for $1 billion back in 2016, you could have bought about 45,000 chips, and today you can only buy about 11,000 chips. But look at the performance improvements that you get. The GPU performance, the time it takes to train a model, and the amount of power you use to run the model is all drastically reduced. So again, continuing to look at energy efficiency and to look at performance and price performance, i.e. value, in delivering the best solutions. Our building blocks today for the AI factory of the future are around the GB200 NVLink 72. As these systems get more complex, we have, again, so many great partners here in Taiwan that are building these individual parts, taking the NVLink switch tray, taking the compute tray, taking the superchip module, and building it into servers. As I said, it's not just about the server. It's understanding how all the connections work and how this works all the way out to the software. thinking about just one component, NVLink. There's been a lot of discussion about NVLink the last few days. NVLink is not just a wire connecting two GPUs. NVLink, now in its 5th generation, is the entire end-to-end system for connecting the 72 GPUs in the rack. Jensen showed the large wiring connector, 6 feet tall, the ability to send a signal out of one GPU through a set of NV switches, through 6 feet of copper, out to another GPU. NVLink, in a sense, starts with software inside the GPU that initiates the communication, goes through the entire set of switches and cables, comes out the other end, and makes those two GPUs, those 72 GPUs, act like one giant GPU. Now, building the AI factory is a lot more than just putting the servers in the rack. In fact, the rack comes pre-built in the factory. 2 miles of copper cables in the back of the rack. It weighs several thousand kilograms. You have tens of gallons of cooling liquid per minute flowing through the rack all the way to the GPUs. And it consumes 120 kilowatts of power. What it saves is thousands of kilowatts of power compared to older GPUs. Again, this system will cost millions of dollars, will start being deployed soon, this year, and we're already in the process of planning very large data centers around the world for our partners, very large AI factories that will be deployed in every large cloud, in many regional clouds, and in private data centers by private companies. So, if you're not quite ready for this 72 GPU rack, we of course have smaller ways to get started. One of the new products we announced here this week at COMPUTEX was the GB200 NVLink 2. It's an industry standard MGX server that fits in any standard rack, and it puts together 2 of the GB200 superchip modules connected by NVLink. Very easy to deploy, very easy to scale out, and ideal for inference. Remember, as Jensen has said, training the AI model, that can be done anywhere, subject to constraints of where your data is. AI doesn't care where it goes to school. You don't always have to train your models in the city or the country or the data center. You can move that training to places where energy is less costly and more available. But then when you run your model, you want to run your model as close as possible to where the activity is. So this GB200 NVLink 2, being able to fit in a standard server in any data center of the world, is super important. Now, going the other way to build an entire data factory, one rack of NVLink 72 will not be enough. You, of course, read every day on how companies are using thousands or tens of thousands of GPUs to build AI models. So, how do you connect together multiple of these racks? Again, this is very different than normal data center or normal cloud, where you would simply take your racks of web servers or database servers and connect them together with regular networking. An AI factory is, of course, not regular compute, it's accelerated compute. So the DGX SuperPod with DGX GB200 systems is a blueprint on how you can build an AI factory. This particular blueprint scales up to 576 GPUs in one scalable unit. And then you can then put multiple scalable units together. With the 576 GPU building block, you can go up to 9,000 GPUs. Now, of course, as I said, you've heard of customers using more than 9,000 GPUs today. So we continue to scale up. You can put together using a building block of 1,152 GPUs. You can build up to 18,000 GPUs. So this will be one of our standard AI factories, deploying up to 18,000 GPUs. And to anyone in the audience that would like to build an AI factory of more than 18,000 GPUs, don't worry. Please come talk to your NVIDIA representative or to your OEM partner, and we have designs to scale beyond this as well. And finally, while many people are used to InfiniBand networking, which Jensen showed continuing on our roadmap, for people who absolutely want to or would like to use Ethernet, we can now build AI factories with our Spectrum Ethernet. So I'd like to thank everyone for being here today. Thank all of our partners that make the NVIDIA AI factories possible. We cannot build any of the AI factories. We cannot IBTG without these partners. So thank you very much.
Thank you, Mr. Hamilton, for your inspiring presentation. Now, let's move on to our next speaker, Mr. John Solomon, Vice President and General Manager of Chrome OS at Google. He will show us how Google facilitates AI applications for everyone around the world. Ladies and gentlemen, let's welcome Mr. Solomon to the stage.
Hi, everyone. I'm really excited to be here. You know, you're probably not used to seeing Google at COMPUTEX. And in fact, I had to look up, when was the last time Google was at COMPUTEX? Turns out it was 14 years ago. Okay? It was actually our big boss, Sundar Pichai, was actually here, although he wasn't the CEO at the time. And he was here to talk about the fact that, in fact, Chrome operating system was establishing a development center here in Taipei. But you know what I think is more interesting is the fact that Google is here at COMPUTEX. What does this say to you about the nature of the time we're living in? About what a transformative time this is, and how generative AI is really an incredible inflection point in our industry, that we're going to look at this point in time, and it's just going to be such an amazing transformation that we're starting to go through. So my name again is John Solomon. I'm responsible for Chrome operating system at Google, as well as our education products. And I'm super excited to be here with you today. And I'm hoping by the end of this short presentation, you're as excited as I am, and as we are at Google, about this amazing opportunity to bring AI in a meaningful and responsible way to millions of users, more than millions of users. So to get you in the right frame of mind and a little taste of what to come, we're going to roll a quick video.
Allow me to reintroduce myself. My name is...
What does this remind you of?
Schrodinger's cat.
Wow. Okay.
When all of these tools come together, it's a powerful combination.
It's amazing.
That's amazing.
It's an entire suite of different kind of possibilities.
Hi, I'm Gemini.
What neighborhood do you think I'm in?
This appears to be the King's Cross area of London.
Together, we're creating a new era.
Yeah, welcome to the Gemini era. You know, there are three main messages that I'm going to be sharing with you today. First of all, Google is the undisputed leader when it comes to AI innovation. And Gemini is our most capable AI model. Now, Gemini is not just another model. Gemini is unique. It's unique relative to other models in the marketplace in that it's natively multimodal and scalable from cloud to on-device. I'm going to share several use cases of how we're using Gemini in our products today. And I'm going to show you a sneak peek of some amazing future developments that are coming. And then last but no means least, I will talk about how this is only possible with deep collaboration with partners. Many of you are in the room here today. Now, you're probably aware Google has a very strong mission statement. Our mission is to organize the world's information and make it universally accessible. And AI supports Google's mission because AI allows us to make things more to make accessing information, being productive, and doing it in a more helpful way, in a more productive way, to improve the gaining of knowledge, learning, to improve how we can be creative and productive, and to build the most helpful platforms and devices. With our AI products, and specifically with Gemini, we'll enable others to innovate and to grow. And we'll do this all by building and deploying responsibly. Now, you're probably quite familiar with Google products, but you may not know that we have 15 products that each serve 500 million users. And we actually have another 6 products that are used by over 2 billion users. So Google is differentiated with incredible reach. And our intention is to bring Gemini to life through the incredible reach and distribution of our applications and services. Now let's talk a bit about Gemini. You saw it a bit in the video. What's the deal with Gemini? So Gemini is our most powerful model, and it is differentiated. First of all, it's a scalable model. This is important because we can use the same model, the same core architecture, from our most powerful Ultra all the way to on-device Nano. And by having the same fundamental underlying architecture, we can innovate very, very fast and bring the features and capabilities in a waterfall fashion down to smaller models over time. So as the models iterate and keep getting better, and the learnings from the large models gets transferred to the smaller models. And this is a continuous waterfall process. So the scalability is really important. But Gemini is more than that. Gemini is natively multimodal. What that means is it can ingest video, code, text, images, all of these seamlessly. And the third thing about Gemini, which is unique, is the largest context window of any large language model out there, with a 1 million token large context window. Now you might say, what's the deal? 1 million tokens sounds like a big number. Yeah, it's a big number. The relevance of this, with a large context window, you can take in a single prompt, an incredible amount of information. You know, I was joking with some of my colleagues here in the industry that we're all aware, having worked in this industry, of these dense and very long technical manuals that accompany new platforms, new SoCs, new technologies. With a large context window that we have with Gemini, 1 million tokens, you can absorb and summarize in one prompt a 1,000-page PDF, a 50-minute video. And we have the 1 million context window shipping available today, and we have a 2 million context window, which is already available for developers. Now, we'll bring this to life through these products that you know and you use in your daily life. Now, instead of me talking about this in theory, let me give you some specific use cases that you can identify with, then you can experience in your everyday life. So I'm going to talk about how we're putting Gemini to work across 3 well-known products and platforms. I'm going to talk about how we put it to work in Workspace. Workspace, of course, is our very popular productivity application. Hopefully, many of you use it. Used to be known as G Suite, renamed Workspace a number of years ago. This is your docs, sheets, slides, right? The second area I'm going to talk about is how we're using Gemini in Android. I'm sure many of you are lovers and users of Android phones. There is no operating system that has the kind of reach that Android has, with over 2 billion users. And then my last and favorite one is Gemini on Chromebook Plus. Of course, it's my favorite because that's my day job. I'm responsible for Chromebooks, and I'm going to talk to you about how we're bringing Gemini on Chromebook Plus. So I like videos, so we're going to use videos for at least some of this. So let's first look at a video of how we're going to use Gemini in docs, sheets, and slides. This is in Workspace. So if you could roll this video, please. You know, I love this video because it's, to me, so practical and real. It shows things that I'm sure many of you do in your daily lives, right? I don't know about how it works in your companies, but you know, these long emails, you need to summarize them. Everyone's piling on. We're all trying to create a correspondence that is personal, but we've always got, you know, a long inbox. And so what you saw in that video was a host of really helpful, productive capabilities that Gemini brings to Workspace. And the great thing is, this is not some future capability. This is available for use today. The next thing I want to talk to you about is Android. That's on the screen here behind me. So I talked about it, 2 billion users. So the way we think about Android is we're really using Gemini to reinvent the user experience on Android. Gemini is native on Android. You get an integrated experience. It doesn't feel bolted on like someone else's application. It feels native. It's in the operating system. And in fact, Android with Gemini Nano is the first mobile operating system with a multimodal, on-device language model built into the operating system. It's available on Pixel and certain Samsung phones, And it'll be rolling out to more of the Android ecosystem in the coming months and quarters. Gemini operates integrated into the operating system and as an overlay. It's important to have an overlay because it's aware of context, of what are you doing. In these examples that we're showing on the slide here, you can see classic use cases, obviously, that we all do on our phone. We may be looking something up, doing some research. Gemini can help you there. You may be simply doing messaging, creating a message to your family, to your friends, inserting imagery into that in a very helpful way. And then, I don't know about you, but I still use my mobile phone for phoning, for calls. Well, Gemini on device can screen calls, can eliminate spam, super useful things. Okay, now, the third thing I want to talk about, I mentioned this is my favorite, was Chromebook Plus. Now, many of you who maybe don't work on Chromebook don't know what this is. So let me take a moment to explain. Chromebook Plus is a higher tier of Chromebook, and it's designed specifically to be a vehicle for Gemini. We launched it only late last year, and it's already been extremely successful, very well received by customers, by reviewers, and by our channel partners. And it's enabling us to bring the very best of Gemini to the desktop. So we're creating the best AI laptop. And the data speaks for itself. So since we launched this product, we're seeing that the average Chromebook Plus sells for 50% higher than the average Chromebook. So users are coming in and they're seeing the value and they're willing to pay a lot more. Customers love it. But here's the interesting thing. Even though it's 50% more than an average Chromebook, we just launched 7 new Chromebook Plus devices 2 weeks ago with all of our OEM partners, many of you in the room here, and of course ODMs who built these products. And the price of these products, listen carefully, started at $349. $349. Going up to $699. Now, this is radical. This is the power of AI at accessible mass market price points. Now, many of you heard about some really fancy AI that others have been talking about this week here at COMPUTEX. But none of these products are under $1,000. So this is another amazing differentiator that we can do with Chromebook and AI. And you know I love videos, so I'm going to show you a quick video. Roll the video, please.
Whoa.
Okay, so if you didn't grab you there, what you're seeing is on a very affordable laptop, a Chromebook Plus, starting at $349, you have the amazing power of Gemini. And this is just incredible, right? Now, no presentation from Google would be complete without a sneak peek into the future. You're always interested, people are always stopping me, what's coming? What should I expect? So we have some very cool things we want to talk about that I'll just briefly tease you with. So hands-free control, this has been something that many of you have worked on. We know it's important. Accessibility, right? We all know this is important with the world we live in, the population, the aging demographic. People need to be able to interact with computers in new ways. So we're super excited because we are taking hands-free and really new form of modality to Chrome OS, and we'll be bringing it out later this year. Now, what you're seeing in this GIF behind me here is the user, this lady you can see in the image. She is composing and sending an email. She's opening and using an application. She's browsing the web. She's doing all of that without touching the keyboard. All of this is being enabled with her face, with gestures, and with her voice. And there's no third-party software involved. This is all integrated into the operating system. This is possible with AI. You cannot achieve this without AI. The kind of precision needed, the learning models required. So, super exciting thing coming down. Now I have another one to talk to you about. This one is also going to involve a video. Please bear with me here. But this is important. So what I'm going to talk to you about here is multimodality. So we've talked about Gemini being a multimodal model. Text, video, images, right? But the important thing is having multimodality with context is where you get real power. The intersection of context, knowing the context, and then having these multimodal inputs creates an amazing, intuitive, natural experience. So I'm going to give you a video here. Some of you might have seen this video. We showed some of this at I/O of a project called Astra. Not yet released, because I said it's going to be a future thing. But I think you will share with me a sense of amazement and wonder, because this just shows you what's possible when you combine Gemini with context. So if we could please roll this video. Thank you.
Okay, let's do some tests. Tell me when you see something that makes sound.
I see a speaker, which makes sound.
What is that part of the speaker called?
That is the tweeter. It produces high-frequency sounds.
Give me a creative alliteration about these.
Creative crayons color cheerfully. They certainly craft colorful creations.
What does that part of the code do?
This code defines encryption and decryption functions. It seems to use AES-CBC encryption to encode and decode data based on a key and an initialization vector, IV.
That's right. What neighborhood do you think I'm in?
This appears to be the King's Cross area of London. It is known for its railway station and transportation connections.
Do you remember where you saw my glasses?
Yes, I do. Your glasses were on the desk near a red apple.
What can I add here to make this system faster?
Adding a cache between the server and database could improve speed.
What does this remind you of?
Schrodinger's cat.
All right, give me a band name for this duo.
Golden Stripes.
Nice. Thanks, Gemini.
Pretty cool, right? This was a single take video made in our London office using Astra, powered by Gemini. So it's cool stuff to come. Now, none of this can happen without really close and deep partnerships, whether it's for our cloud devices, our cloud servers, or our endpoint devices, our phones and Chromebooks. So we really need to be able to partner very closely. And that's the way we make it affordable and accessible for all. So when we think, for example, of Chromebooks, right? What's really important to us, that our partners, many of you here in the room, that you can share in this new wave, and you can actually grow your businesses in a profitable way. So we think about this through 3 pillars. One is, to drive growth, the products have to be desirable. You know, we all know that if a product has only utility value, we're not that excited about getting a new one. But when a product's desirable and exciting, we want to come back in the market, the consumer wants to come back and get something new. So that's why we believe that AI can be really important in making the products more desirable. But we've also realized we need to have a more streamlined portfolio, which actually sometimes means having fewer products, but putting more energy and focus on the products you bring to market and just doing it really successfully. And the third one is, it needs to be more flexible to bring up these designs and to be able to leverage the incredible supply chain capabilities ODMs and OEMs have. So we know it's the combination of these 3 things: desirable products, a focused portfolio, and supply chain optimization that will really drive a virtuous cycle and make the flywheel work for all of our partners. And we're very focused on that. Now, as you know, these models are not something that one can just deploy and expect good results. In order to get the results that the user expects from their device and at the server side, we need to do optimizations. And we are very reliant on close collaboration with you when it comes to things like battery management, when it comes to power optimization, when it comes to memory. You know, much of these models can become, or use cases are memory bound. And so what we've seen over the past few months and quarters, real breakthroughs by deep collaboration across the hardware scheduler, across the whole system platform, to create the magical experiences that we're able to deliver for consumers. So really, really excited about this next level of collaboration that this is bringing to fore. So let me recap. AI should benefit everyone. Google is very focused on mass market AI, making amazing experiences to very affordable price points. We're doing this by bringing the power of Gemini through our incredible distribution of products and services that I showed you, whether it's productivity, different apps you use, Chrome OS, Android. So we'll be doing that, and we'll continue to do it that way. And then, what's better for you is better together. This deep collaboration with all of you as our partners. And with that, I just want to thank you for this great opportunity to talk to you. I hope you enjoyed the talk. Thank you.
Thank you. That was a fascinating presentation by Mr. Solomon. Up next, we have Mr. Thomas Anderson, the Vice President of AI and Machine Learning at Synopsys. He will provide an overview of recent AI trends and share insights on how generative AI technology can be applied to optimize and automate chip design tasks. Welcome, Mr. Anderson. The floor is yours.
Okay. All right. Thank you. It's an honor being here. This is the first time that Synopsys is presenting at COMPUTEX. I was intently listening to my previous presenter from Google, and I have to out myself. I'm an Android user. Not just that, I have a Pixel phone. I'm a happy user of it. And we're going to talk about something very different today. We're going to talk about the software that's being used to build the chip inside those phones and many other devices. So that's what Synopsys does. Our motto is Silicon to Software, and we essentially built electronic design automation software that helps you design those super complex chips in there. And for us, we're using AI to design those chips. And the funny thing is, you're using AI chips. You're using AI software to design AI chips. So it's kind of like a self-fulfilling prophecy. You should also know, just like the first speaker today, I'm also a famous actor. If you look at my name, maybe anybody remembers The Matrix, Neo, Thomas Anderson. So, but you know, they replaced me with AI now, so therefore I changed my job and I'm working at Synopsys now. All right, so over the past years, I think we've seen a reinvention of computing. It used to be all focused on CPU and pushing the frequencies and adding more cores, and now we have AI accelerators. We have GPUs, of course, and as a result of that, an explosion of intelligent systems. I would say, again, reference to my previous speaker, the most useful thing, this is a very cool presentation from Google, the most useful thing to me was asking the system where my glasses were, because I constantly, I check where did I put my keys. So if I have a system that tells me where I put my keys, oh, you forgot it in the refrigerator next to the eggs. That would be very, very useful. All right, so let's take a look a little bit at some of the trends that we have. The first one I think is obvious. So in the generative AI space, I think we can expect that many design jobs like mobile web applications, for example, will be automated. So here's an estimate. In the next 5 years, we expect that 70% of the web or mobile applications will be done more or less automatically, which makes sense if you think about it, because there's a lot of, I would say, repetitive stuff or building blocks that can be reused. And as a result of that, and many, many other things, of course, we expect by 2028 a huge increase in workloads at AI and data center. And that, of course, is also driving this AI chip boost, essentially. So let's take a look at some of the data that's been generated over the years. And you can see here there's sort of an inflection point. You see at the very bottom, like this orange-yellow piece, it's hard to see because it's so small, is human-generated data. So these are things that you're typing, that you're writing, that you're drawing. And up until, say, 2018, this was still dominating. And you can see now that since then, machine-generated data is taking over. And in fact, you see an exponential growth. And if you also look at this graph, you see sort of a breakdown. You think, well, most of the data generated is maybe social media. But that's not true. There's a lot of industrial data that can be used to essentially optimize processes. There's home IoT solutions like Alexa and Google and things like that. And there's also, you can see a big part there, automotive. When people think AI, they oftentimes think about self-driving cars. And there you can, of course, log millions of miles and generate a lot of data and hopefully learn from them to be better than a human. We're not there yet, but hopefully we will be. And new AI models, if you look at this graph here, you can see they're pushing the limits of compute. In fact, you sort of see another inflection point. You see where with transformer models, the required compute is increasing about 275x over 2 years. And if it's exponential, of course, that number will go up more. And you can see here, this isn't even showing the latest one. This is still GPT-3. And as a result of that, it puts huge constraints onto computer chips and the demands for building those. So at the heart of all this are essentially what we call AI superchips. I have a few examples here. I know we've seen a lot of Nvidia examples. We've seen announcement from AMD, from Intel, from Qualcomm at COMPUTEX this week. Here's two very, very super large examples. One of them is a Cerebras waiver scaling engine. So you can see there's a lot of repeated structures in there because these are essentially thousands of repeated cores. And they're used, for example, for specialized applications in medical research, things like cancer research, even COVID-19 research. They use these types of AI superchips. Another example is from GraphCore. That's a European company that also has these super, super large chips. In fact, I've seen a picture when you hold them up. It's about this size. It's incredibly large. So that you have that on one end. On the other end, you have the edge IP. So things like on your mobile devices or in a drone. And they obviously need to be extremely small. and the power consumption needs to be extremely low. And in both of these different types of spectrums, so one is all super high performance, the other one is essentially medium small performance, but very, very power optimized. For all of these, you need to design specialized chips, and you need the software to do that. Now, if you look at chip design, many people that are not familiar with this, and maybe they come from the software world, they're astonished how long it takes to build a chip. It's not like you writing software and in a few months you have it and you compile and out you go. There is many complex steps involved. There's many iterative loops like architectural design, structural design, logic design, ultimately layout design, so that's the physical representation, that then gets sent to, for example, TSMC or Samsung foundries to actually put it on a wafer and make sure it works. Make sure it works functionally, it meets performance requirements, the yield is acceptable, because otherwise it's cost prohibitive. So as a result of that, typically tens to hundreds or maybe even thousands in some cases engineers are spending their time building and optimizing these chips, and it takes upwards of 2 years in some cases to build a new chip. And the beginning of electronic design automation software, which essentially replaced doing manual design, like drawing logic or even transistors level in the analog world, replacing them with automated tools, started in the late 80s. And since then, we estimate we've done something in the range of 10 to the power of 7 in design productivity, which means today, instead of having tiny little chips with a few hundred logic gates, you essentially have many millions of logic gates on a chip, and you can still do that in a reasonable amount of time. So that's obviously a very big challenge. On top of that, and again, driven by these exponential curves that you see here, there is an ever-increasing complexity in the size of the chips. And we only have limited amount of people. There is a projection that you see here in the middle from, I think, Boston Consulting Group that estimates a 30% talent shortage by 2030 in terms of designers needed to build those chips. So how do you overcome this? I think the only way to overcome this is using artificial intelligence to essentially automate some of the tasks that are humans doing today. And we're starting, I would say, with more mundane tasks, because we don't want to take away the creativity and the brains that the humans have. In my opinion, at this moment in time, and I can't say in the further out future, but at this moment in time, there's no AI system that possesses the creativity of a human being. However, there's many useful applications where, like similarly to what was shown in the Google slides, where you can automate certain tasks, like composing emails, summarizing things. The same thing applies to our world. There's many tasks in chip design where people don't actually want to do that because they're boring. You want to have a system that looks through log files of your runs and figure out what to do next, and optimizing for performance through tweaking parameters in your system. For these kind of things, I think AI applications are very useful and also very welcomed by humans because they do a task that is kind of boring. So that's sort of the catalyst for AI design. And I mentioned in the beginning, the funny thing is that we're building AI software to build AI chips, and then they run on AI chips to build the next level chips. So it's actually a very interesting loop and sort of a self-fulfilling prophecy. So let's take a look a little bit about what's different in our world. So we're not Google or Facebook who can collect essentially millions of images like this. You can look at it. Is this a chihuahua or is it a muffin? We actually have this joke in EDA that we deal with images that are not cats or dogs, but other things, right? So anyway, it's very obvious if I train a system with millions of examples, even though you have to look closely to figure out which one is a dog and which one is a muffin, I think easily, of course, the system can figure that out with enough training data. Similarly, let's talk about self-driving cars. If I log millions of miles and I essentially have every possible scenario that I encounter, I ultimately should be able to outperform a human, because how many human drivers have seen all possible scenarios? Most of the time you drive around, you have theoretical examples of what would happen if, say, a kid runs in front of you, or like a particular scenario where maybe somebody breaks and you need to do an emergency evasion maneuver. People go to driving school for that, to get those specialized skills. If I get all this in the system, I have no doubt that a system could outperform a human and be much safer. But I can train the system with lots and lots of data, because I can just go out in the real world and train it. Unfortunately, in our world, things are a little bit different. Since we're building chips, essentially, there is literally very limited amount of public data. It's typically what universities have. There's open source cores, very log descriptions, and so on. But of course, the cutting edge technology, they're all compartmentalized. And every company, of course, be it Nvidia, AMD, or Intel, of course, they want to protect their own IP and their own intellectual property. Therefore, they guard their data. And therefore, the only way to train a system is to train it on-prem at essentially the chip maker itself. The other thing that's interesting is we have rapid changes in technology nodes. Like every 18 months, and that's accelerating, you get a new technology node. Like TSMC comes out with 5 nanometer, 3 nanometer, 2 nanometer chips, and every single time things are changing. It's as if you were driving your car, and every 12 months they change the rules of the road. They have different signs, and they say, okay, now you need to yield here, and you don't have to yield there. So you have to constantly adapt. And that makes our job, in comparison, much more difficult. Nonetheless, Synopsys has been the pioneer in AI-driven chip design by essentially offering a number of breakthrough capabilities. We started in 2021 by by introducing what we call design space optimization, or DSO.ai. That's essentially the paradigm of using AI for an optimization tasks. So you have complex tools, and you have workflows around those tools, and you need to meet certain performance requirements: power, area, frequency, of course, because you want your highest performing chips. Traditionally, the humans are essentially designing scripts around systems and workflows, and then they optimize them. It's a very tedious process. We developed essentially an AI optimization system using reinforcement learning that can do the same job that a human does, in fact, can do it better. And I'll show you some examples on that. The second thing we have is data analytics capability. I think the most maybe plausible or explainable scenario is when you look at yield, for example. You want to build a chip that has high yield. That means when you produce it, you have very few failures. For this, you need to essentially analyze large amounts of data and find patterns that are causing these failures. For that, we have developed data analytics capabilities and essentially help the human to identify this. And the third thing, and that's of course the big topic today, is generative AI, where we've invested in a number of capabilities, starting from co-pilots to help you run and optimize the tools, all the way to generation of actual inputs. So in this case, it's not emails. It's things like, we call this RTL. That's essentially a hardware language description of how the chip should operate. And you can build systems that help you generate this from a natural language description. But first, let me look at some examples of the AI optimization. So my team actually pioneered this work about 5-6 years ago, and we launched it in 2020. And originally, my goal was I wanted to be as good as a human doing this task manually. Again, this is an iterative task. You essentially run EDA tools many, many times, and you try to tune it to optimize your performance. Originally, I said, okay, we're going to do it faster, but we're not going to do it better. We're just going to get the same results as a human. And then what happened is we actually got better results. And every time when we went to one of our customers, they said, whoa, you actually have a much better result. And after a while, we figured out this is a task that a machine can do better than a human. And here's some examples. So you can take a chip. These are all from big customers. You see them at the bottom. They're quoted: AMD, Intel, Microsoft, Nvidia, Renesas, and so on, Samsung. So whether it's shrinking a chip, reducing your die size by 12%, that's a huge cost saving. Reducing the power, of course, is very important for various reasons, not just power consumption itself, but also battery life, of course, heat that's being produced in a data center, and of course, things like frequency. Everybody wants higher performance and faster frequency. So there's many examples where this is actually showing better results than a human could do. So let's take a look at generative AI. And I think generative AI, I think one of the first speakers said it, isn't necessarily new. It has just come, it's gotten popular since we now have large language models. So we now essentially have systems that have been trained with billions of weights, a neural network with billions of weights, that has all the information that's out there. And when it comes to pure knowledge, I mean, it is wrong at times. We've all seen that. We've seen hallucinations. But when it comes to pure knowledge, I think nobody will question that it can beat any human, because none of us has studied and read every single book that's out there and can know exactly what was written on page 254 of a particular book. What is, I think, interesting is that you feed it the right information, because when you tune the system, you have to make sure that actually the answer comes out, essentially processes maybe potentially conflicting information and gives you the proper answer. So let's look at chip design. Generative AI chip design, what could it do, for example? One simple thing would be support assistance, automation of workflows, generation of inputs, like similarly to, say, GitHub Copilot, where I write C++ code and it auto-suggests. In this case, you can build a system that generates RTL. Again, RTL is a hardware description language that describes how a chip should operate. And of course, in general, content creation from some human language spec. If you look back, chips are actually created based on an initial human language spec. So there's documents that describe precisely how the chip should operate, what it should do. Taking those and translating them into actual consumable input for EDA tools is extremely powerful. There's, of course, a number of challenges. The big one for us is things like copyright IP protection. As I mentioned earlier on, a lot of the data that we need is not in a public domain. So it needs to be trained on carefully selected data with the right background. The problem complexity, of course, is also much harder. We're not talking about just self-driving cars or summarizing emails. We're talking about designing chips. So the task here is much more difficult. So late last year, we introduced what we call Synopsys.ai Copilot, and that is the industry's first generative AI-driven EDA stack, and we launched this together with AMD, Microsoft, and Intel. This is essentially the expansion of our AI technology towards generative AI, and it includes what we call collaborative, generative, and autonomous capabilities. And I'll show you a few videos in just a moment that give you a little bit glimpse of what it actually does. In fact, here's the first video coming right up. So this is our Synopsys Copilot. You have essentially a tool where you implement a chip, and you have a Copilot window where you can ask human language questions. Very simple things. How do I set up my tool? How do I, for example, check my timing of my chip, make sure that I don't have violations? You can see there's links to trusted documents in there. We also process multimodal content, and you can see here in just a moment, for example, you will have graphics, you can even have videos that you can look at, and they show you examples of how to do things. Now, if you think about this, ultimately, this becomes the brain of all your information that you have. And some of this information is today in documents. And you just feed it in the system and then it tells you. But a lot of this information is in people's heads, which is why we spend time essentially training our system with expert knowledge. And then, of course, you can ask follow-up questions. You have a chat interface where you say, what about this, what about that, and ask even questions specific to the very design that you're working on. So you may say, OK, well, that's interesting, but that's not all that exciting. It's okay. It's a Copilot. It answers questions. It gives me suggestions on what to do. But I have something much cooler than that. And in fact, I think it was Mark who mentioned about agents. So the next level of LLMs is not just answering questions, but it's an LLM agent system. And that's essentially a capability where I now take an action. So I have an LLM, I give it a memory, I give it a task, and I tell it to execute something. So in this particular case, I have a chip design. It's not meeting my performance requirements, and I simply tell the system, fix it for me. And the system behind the scenes generates essentially a number of tasks. They may even fail. And then the system learns, aha, this didn't work. I'm going to try that instead, until it is actually able to complete the task. So that is extremely powerful. And the way this works is through the same Copilot window, I load up, in this case, a chip design. I have what we call design rule and timing violations. And I simply say, hey, please fix them for me. That's all you have to do. And in the system, you can see it sort of on the left, it executes in the background a number of commands. These are not pre-configured scripts. These are things that, based on the context you were asking, it essentially generated. It gives a little task. It checks on the response. If it doesn't work, it does something else until it is able to fix the problem. And in this particular case, probably hard to see, but you can see here at the very bottom, you started with a design that had violations. It wasn't possible to tape it out. And now I have 0 violations left. So my timing is met. To me, that is incredible, because that is the next level of automation. A system that I actually give a job, and it is able to do it for me. And remember how I said in the beginning, we don't want to take away the creativity from people. So creativity, I think, is still important. But what we want to do is we want to automate typical tasks. So tasks that people maybe have done hundreds of times. And we want to make this power available to all the users. Let's, for the moment, assume you have a company and you have 100 chip designers. Out of those 100 chip designers, 5 are your top experts. If I train my system with their knowledge, then essentially I give the power from those 5 expert users to all hundreds of users. That is the power of generative AI. So these are some early results on the Copilot capabilities that we have, and some of the things that I've demoed with you. You can see here some quotes. So we're seeing something like 30 to 50% productivity improvement. In fact, there's a quote that talks about junior engineers are now operating at the level of expert engineers. And that's exactly what we want. You put the power into everybody's hand. And responses are much faster, of course, than having to ask a person or looking up in some documentation and find an answer there. I also wanted to mention, of course, our work with Nvidia. I already mentioned that I'm also a famous actor, just like Mark Hamilton, maybe even more famous. But beyond that, we're working closely with Nvidia on enabling them, of course, to build their chips with our software. In fact, all the announcement that you've seen so far from AMD, from Nvidia, from Intel, from Qualcomm, they all use Synopsys software to design their chips. So we have a very, very tight relationship. In one of our corporate events, we call this SNUC, this is our user conference, that happened earlier this year. We had Jensen on stage with our CEO, Sassine Ghazi, and Jensen was telling how we were the first company for chip design software that he ever wrote a check to. And now, of course, they're a very, very big and expensive company. They're very successful, and we're very happy
that they're still our partner now that they've grown so large and they've become so successful. And we've been essentially working with them on many, many things: verification, design, simulation, manufacturing, including generative AI. And we're, of course, using the NIM service that was mentioned by an earlier presenter. So that's one of the backbones of making sure that our generative AI applications work as effectively as possible on top of Nvidia GPUs. So, in summary, Synopsys.ai is mission critical in the area of pervasive intelligence, and it's enabling users at every stage of chip design to make big breakthroughs. And we're pioneering the next level of generative AI capabilities. Again, from going things like AI optimization that was inspired by AlphaGo. Remember AlphaGo? AlphaGo is a reinforcement learning system that was able to beat the world champion in Go. And that was a very, very difficult task because unlike chess, which could be cracked with just sheer compute power, I don't know if any of you remembers in the late 90s, the IBM Deep Blue supercomputers that essentially finally beat Garry Kasparov. That was more in terms of using raw compute power. Like I calculate so many steps ahead, and then at some point I can beat a human. But a human, of course, doesn't work that way. So reinforcement learning in AlphaGo was introduced around 2016. For us, this was the inspiration to build AI optimization for chip design. And that's one of the things I mentioned earlier, showing you the big performance gains that we've had. Since then, we've added, of course, with the introduction of OpenAI, the generative AI capabilities. That is available on OpenAI, but is also, of course, available on many open source models for on-prem installation. And I personally think this will revolutionize the way chips are being built. And that essentially enables building larger and larger chips using the automation of AI. So AI is the only way forward. Thank you very much.
Thank you, Mr. Anderson, for demonstrating the power of chip design in accelerating AI development. For the last session of this morning, we will hear from the enterprise strategist at AWS, Mr. Xia Zhang. He will illustrate how to develop capabilities to harness the potential of generative AI. Let's welcome Mr. Zhang.
Good morning, ladies and gentlemen. My name is Xia Zhang. I'm from AWS. So we heard 3 presentations in the morning. Let's switch the gear and to hear something a little bit different. I'm trying to tell you, in the era of generative AI, how enterprise, and including all the business and IT people, we can take advantage of generative AI and lead the digital innovation. So in the process, I will share also AWS provided cloud-related service to help you to achieve that. So we all know, like people said, beginning from the November of 2022, ChatGPT released, and it offered chatbots, search engine, and it touched everybody's life. So people start to feel the power of generative AI. And then actually, the real power of generative AI is far beyond just search engine and chatbots. And we believe actually all the companies, all the industries will be impacted by generative AI in the coming years. And will change many things, including how we live and how we work. So just for general easy purpose, usually we put the effect of generative AI in 4 large categories. So this is like, change the user experience, provided a new, innovative, and engaging way for people to work. And also, it's widely believed it will change productivity. Actually, Goldman Sachs has a report that says in the next 10 years, generative AI will provide somewhere around 7 trillion incremental GDP growth. And it also says it will provide productivity gains averaging about 1.5% per year. So that's a lot of productivity increment. And also, we believe generative AI will be used widely to provide business insights. So all the data will be analyzed and then will be used to gain about the market, about the product information, about the customer experience. And then the last one actually is something we're not sure yet. So we believe generative AI will give everybody a lot of opportunity to create brand new things. And basically, there may be some new killer apps. We still don't have any idea where it will come from and how it will change our life. So generative AI is a big thing, but actually, like my team, the enterprise strategy team, we consist of formal CIOs from large enterprise worldwide, like my teammate from Coca-Cola, from Capital One, and from many of those companies. And when we engage the customers actually now are all looking into how to use generative AI to help their company to create value. But they run into a lot of problems. And here I give you some of those. For example, like how to really assessing those multiple foundation models, including how to select them, how to make them customized to fit their own data and the company, how to really make sure the data will be safe and secure and it will be kept in their own enterprise, not being shared unwillingly by other people. And also how to make sure it can build into generative AI apps and help you to execute your task. And things like that. So yeah, easy way, customer basically ask a couple of questions. Which model should I use? And how can I move quickly and begin my AI journey? And then how I can keep my data secure and private. Those are some of the fundamentals questions we met. And I believe our friends sitting here today probably have similar questions. So we want to give you a simple, easy, 3-step platform, how you can think about those and how you can help your enterprise to begin your AI journey. So the first thing actually is not a technical decision, it's a business decision. So for every company, the first most important thing is you need to work with your company executives, the CEO, the chairman of the board, all the leadership team. You need to decide what business scenarios, what business case you need to work on. That will give you the biggest impact and also give you a good return on your investment. So let's take a look, in this area, what kind of thing we can suggest. First, people believe generative AI will basically have very broad impact to every industry, to companies of all sizes, large and small. And here I listed some of those companies, industries. So you can see actually for healthcare industry, there are many things you can do. You can talk about medical imaging, drug discovery. You can talk about how to enhance the clinical trials. And for other industry, media and entertainment, you generate a broadcast content, you optimize your subscriber experience, and so on and so forth. Almost every single industry will be impacted. And here I have a little bit of a quick flip through. Actually, if you look into the details of each industry, you need to identify some particular areas that you believe that will differentiate company in that industry. And here I gave a simple example of Merck, a well-known pharmaceutical international company. And they do very simple things on AWS. For the drug manufacturing process, there are so many steps, so many things you need to consider. And then they gather the manufacturing data and put it into an AI model. And they are doing a very simple thing. They use that data, building a model, and implement that into their manufacturing inspection process. And then they claim actually they can, using that synthetic image with their customized model, they can reduce the so-called false rejects by 50%. So basically, that's something you think the drug is no good, but that's not true. So this way you can see that's almost immediately, that's 50% of money saved. And then, so we can see actually choose the right business case is the most important thing. And our suggestion is for IT leaders, you probably want to select something that's important but not critical. So that's something, when you do it right, your company will be able to get benefit from it, to differentiate yourself with the competition. But at the same time, you don't want immediately to working on something which is super critical for your company, for your cash flow. And because if you do that way, if you do something wrong, the whole company will be in jeopardy, and you will be under spotlight, and you will be endangered your own career. So in that process, you help the company to build up the capability. So the second thing very important is about the data. I think one of our last speakers showed a chart and showing how the data is accumulated and how machine-generated data, starting roughly about 2019, already surpassed what human-generated data. So in this case, actually, generative AI application will be built on the data. And the whole AI situation is like a big iceberg. So only about top 10% is what you see. That will be your generative AI application. But behind the water, there are many more things that's very fundamental for your AI success. And that's all data related. You need to have ways to store your data. You need to have ways to build up analytical capabilities. You need to have ways to interconnect your data. And then you also need to make sure the data is both safe and secure, and also be compliant with data sovereignty-related regulations. So in this case, actually, we do help our customer a lot. And we feel data actually is your key differentiator. And by the way, in the so-called digital times, people are doing digital transformation and digital innovation. The most thing actually for a company to do, which is, as an IT leader, you can do very safely, is working on your data, because AI or not, working on the data is already one of the key things that will prepare a company for the digital era. But for AWS, we have a so-called modern data strategy and architecture. And some of the key elements is we call it comprehensive. You need to have a comprehensive coverage of all the data. You need to have them integrated, and then you need to have them governed. That means you keep them safe and secure. So you probably know, AWS will provide it from a simple storage service. It's called S3. That's where most of the data being trained and being used by AI is stored these days. And we also offer 8, what we call it, purpose-built databases, including SQL, non-SQL, including time series, many different graphic, many different specially built database. And then actually this data will be used for a couple of things. First, you can use that to do the so-called retrieval augmented generation. Basically, you port some of the foundation model, but you incorporate all your private company data into that, and doing basically AI assistant and AI improved search, so you can use all your data. Secondly, you can take your data, put it in your on-premise or on cloud in a safe environment, and then you can train them and fine-tune them and get your own version of those foundation models. And then the most advanced thing actually is, since you will have additional new data being generated and getting into your system as a function of time, so the most advanced thing is so-called continued training of the data. So data come in, and then you do both RAG fine-tuning and continued pre-training, and data undoubtedly will play a very important role. So when you do it right, then data of all different kinds, both from the public domain and from your own private company data, will come in, and then those will be used to either do retrieve augmented generation or fine-tuning a foundation model or continued training of your model. And then those will be connected with your applications, and then that will serve your purpose. So the third thing is, actually, then you need, at the current time, start to build your AI capability. This includes, you need to get resource, you need to hire right talent, you need to have all the fundamental AI-related IT capability ready for your company. So I will start with this. Like Amazon, we started AI right from the beginning of our days. So in 1997, when Amazon.com is launched, we use recommendation, we use personalization for the e-commerce. And since then, we've been continuously using AI to enhance our business and create value, including Alexa, the voice service. So for machine learning, if you look at the technology related, it takes full stack of those technology. Roughly speaking, from the bottom layer, you need to have machine learning infrastructure in place. And then you need to have data, then you need to have a machine learning framework. And then on top of that, machine learning tools. And then at the top layer, machine learning applications. So for AWS, actually, we've been released a bunch of cloud services exactly matching those required machine learning tools and frameworks. So we have basically, bottom layer, the infrastructure, the chips, and we have data stack. We have SageMaker in the middle, and then we have Bedrock, and we have Amazon Q. So I'm going to spend the rest of the time give you some quick introduction about those services. I'm not trying to sell you those services, but it's really for purpose of learning. If we look forward, looking into the era of generative AI, what kind of service you need to have, what kind of capability you, as an enterprise, you need to build. And you can select our stuff, or you can use partners, or our friend companies. We can do all different type of stuff. So let's take a quick look at how AWS offer the core 3 layers for generative AI. From the bottom layer is the infrastructure. Cloud undoubtedly is still the most important way to offer your machine learning infrastructure for the storage, for the computing power. And for us, we have those in place, and we also do a few special things. One is actually we also offer some special chips. And at this COMPUTEX, we heard so many things about chips revolution. We see many good examples. But for Amazon, we continue to also work for specially customized chips for AI. So we have training and we have inference. So from the name, you can understand one is for the training purpose, one is for inference when you have the model. And then we are very happy that we've been working with our partner, Nvidia, which is a superstar now. Jason and Lisa, both a superstar at the Expo. Also, our first speaker gave us some idea, how they are going to roll out new stuff in the coming years. But we are very happy to tell you, on the cloud, we are the first to introduce GPU into the cloud instance, starting from our CG1, and then we continue, for example, like P4, that's the A100, and P5 is H100. And then for the Blackwell architect, the new stuff, 200, B200, and so on, we have planned to roll out those very soon. So you can see, actually, sometimes if you want to get those chips and install on your server, it takes time. But very often, we can have those launched very soon, our cloud facility, so customer can use that. And then the other thing is a service, we call it SageMaker. That has been around for 6 or 7 years. That's a fully managed service helping a company to deploy machine learning models from the beginning to the end, taking care of selecting an instance, getting the data ready, training the model, and then implement the application, and at the end, infer and use the result. So this actually now in the new era of generative AI with all the foundation models, we actually we can use this. You can build your own foundation model from the scratch, or you can connect with different type of ready-made foundation models. And you can also customize, fine-tuning, and continually pre-train your model. It's all possible, and it's also a service people use for foundation model operation. And so this is the first layer, bottom layer. Let's look at the middle layer. The middle layer, again, I already talked about, from the simple prompt engineer using Alice models to the fine-tuning, to the RAG, to the continuous pre-training. So there are many ways you can do. And as we go, we will see actually no one model will rule for all. So everybody now understand as a function of time, there will be many different foundation models show up. We saw that in the last couple of months, different foundation models competing with each other and very quickly. But as time goes, we will have more specially trained models for different industry, different subject area, and also multi-model is a big trend. So because of that, we offer this, we believe, a very important service called Amazon Bedrock. And this is actually our way to allow customers to take advantage of many commercial foundation models, as well as open source foundation models. And then you can put your data in a safe, secure, private area, and you can leverage those. So some of the fundamental things, it allows for model customization. It allows you to connect to agents. You can also, build API, you build applications connecting with API. So very simply, Bedrocks help you to have a choice to choose different foundation models, to customize them, and to integrate them in your working production environment in a safe and secure way. So actually, by now, over 10,000 customers worldwide used Amazon Bedrock. And here I want to say, actually, in Taiwan, Zhonghua Telecom is one of the company actually tried Bedrock. And if you go to our website, you can see the quote from their VP talking about their experience. And here I give you another two examples. One is Adidas. Adidas actually, they used this and gave the community of Adidas engineer interface. They can use that to organize their internal information resource and form something like a ChatGPT type of thing, but their own company-owned version. And the other company is a Carrier, global refrigeration company, and they use it actually to look into the process of the customer information, helping to lower utility bills and also trying to maintain better sustainability. So Amazon Bedrock actually currently will be able to let you to select different foundation models, and including some very advanced foundation models like Anthropic Cloud 3, like Meta Llama 3, and Mistral Stability AI, and including our own stuff. So for Anthropic, you probably heard, Amazon invested $4 billion in the company, and we worked with them, and we provided the Bedrock in 3 different sizes for speed and for price. And so we have different level from the lower end of Haiku that provide a quick, very efficient way to give you fundamental results, to something more fancy, Opus, and I give you a lot more intelligence and high-risk performance, and also Sonnet in between. And on the cloud, you can quickly start to use this on AWS cloud. And I suggest any of you give it a try. I did some very simple thing. I just asked, for example, like, can you tell me if you are AWS managing director for Hong Kong and Taiwan, what kind of strategy you would have for the year? We were often surprised by the solution, and some colleagues joking, oh, this seems even more comprehensive than what our leaders said in our annual kickoff meeting at the beginning of the year. So give it a try. And also recently, Meta announced Llama 3, and it's being rolled out by us very soon. Of course, Amazon, we have our own model, foundation model too. It's called Titan, and we have different versions. We have the version that's test embedding, that's actually directly expose the vector embedding for the large language model to you, and also test light, test express, multimodal embedding, and image generator. That's the 5 models currently we are offering. And we are, of course, continually working on those to refine them, to polish them. So here you can see actually with this Bedrock, it provides you this capability. You can start with your data, and then you can select some foundation model of your choice. And eventually, some of the company, they customize the foundation model. They can also develop your own foundation model. And then you can use them for different ways and build, working with your data in a secured enterprise environments, not just through the data to the open internet. And many companies worried about who will be able to get access to your data and your information. So this way, you'll have the data in your own way. You'll fine-tune or continually train your model, and all those are in the closed environment of your own. So Bedrock actually will continue to offer more capability. One is the so-called agents for Bedrock, and that will give you the capability to do AI agents, which is a big thing everybody knows. Basically, it allows you to execute multi-steps tasks. That give you the opportunity to execute a series of different steps depending on the interaction with the user. And then in addition to that, we also have something called knowledge base built on Bedrock and guardrails for Bedrock. Guardrail actually give you a safety security layer, helping to guard both the input and output of your models. So you can easily set up some rules, what need to be blocked, what kind of question, like a financial question, asking something to choose a particular stock. It may give you some suggestion, but it needs to come with a standard disclaimer, or some of the question, if it's not moral or it's illegal, it can help you to block those. So as a summary, this is currently the 3 layers we offer, and we believe from the enterprise point of view, AWS is really leading among all the cloud vendors. You heard it from everybody else. You can compare. And then, in the top layer, quickly, we also offer something called Amazon Q. It's an AI-powered assistant for your work. And that helps you to use your private company information to do an internal kind of a chatbot application. And you can use it also for content generation, video tests, many different models. But, all in an interactive way, using your company information, personalized, secure, and safe. And this actually, Amazon Q, also have different versions already. It has specially tuned for general business, or for just for IT and developer, and also it has for call center. It's called Q in Connect, or for BI, data analytics, QuickSight, and also a version just for supply chain. And there are many different areas for business user, IT user, developer, special needs. You can use those. And you can imagine AWS will continue to refine and polish those as we listen to your customers' requirements. And here we have an example from QuickSight, using QuickSight from BMW. So they put their data, and then they run that in QuickSight, which is our AI graphic display capability. And then that's combined now with Amazon Q to give you that automated capability. OK, so let me summarize. So here I tell you from the 3 layers what we are working on. And just in about a month, we will have our New York Summit. We believe we will have some announcement. And later this year, of course, we will have our re:Invent near the end of November. That's our largest technology event. And we will have more service coming out. So as a summary, we can see we mentioned the 3 steps. Select the right use case, prepare your data foundation, and then actually you can start to build your capabilities and start to have generative AI working for your enterprise. And before I finish, give you some additional recommendation based on our engagements with worldwide customers. First, you want to keep your eye open. Generative AI is so new, and many things is going to change a lot. So have an open mind, have a flexibility to adopt, and keep curious, encourage all your employees to learn. And second thing, flexibility is the key. So you want to build some solid foundation while you want to maintain flexibility for foundation model selection, for some quickly change some tools if needed. And then we know no one size fits all. So you really need to explore what kind of foundation models will really work for you, and whether or not how much you want to do yourself, including some fine-tuning, including continued training. And for most of our companies, at the stage, we don't need to build our own foundation model from scratch, which takes a lot of time, a lot of money, a lot of resource. And then we also suggest you really start to act. So I have 5 simple steps as the last word to you. So you can select the right use case, empower your team, encourage them to learn, and get started on some top use case. And then move to production. Make it real. Make it a real impact to your business. And if it works, you want to scale them. Make it really work across your company. So that's all I have, and really my pleasure to share with you. And AWS, we have our team based in Taipei, and we are in the 100 building, and welcome you to contact AWS Taiwan for any requirements, any support. Our team will be very happy to work with you, to support you, to start the AI journey today. Thank you.
Thank you, Mr. Zhang, for the practical insights to unlock the transformative power of AI. We've had a stimulating morning session packed with thought-provoking presentations, but the conversation doesn't stop here. Join us in the afternoon session where we will explore what lies behind generative AI. Please remember your personal belongings as you leave the room. Thank you, and see you in the afternoon.
lamppost, startups on the grind, chasing their dreams in the realm of innovation.
它是一个异质的文物哈，所以它的耐候性比较强一点。
但是你们做好一个像是保险，还有你有没有限制它出管的这个次数？然后它多久出工之后还要回工啊？你有没有发现？你看这个做完之后，3月10号在台南美术馆，然后呢你在故宫还要回工，只有。
chasing their dreams in the realm of innovation. Nothing's as it seems, networking sessions where minds collide. Ideas sparking innovation as our guide. From the product launch to thought leadership stance, we're carving our path, taking every chance. So let's raise our voices in this digital symphony. Tech giants and startups rewriting history. In the pursuit of innovation, we stand tall. At COMPUTEX embrace where dreams enthrall. Spark, illuminate digital nights. Yes, yes, yes. Tech titan startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. AI nights. Hey. Innovation spark, illuminate digital nights. Yes, yes, yes. Tech titan startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. Yo, check it, it's the rise of the tech scene. Listen close, AI's the heartbeat. Tech giants, they impose startups on the grind. Chasing their dreams in the realm of innovation. Nothing's as it seems, networking sessions where minds collide. Ideas sparking innovation as our guide. From the product launch to thought leadership stance, we're carving our path, taking every chance. So let's raise our voices in this digital symphony. Tech giants and startups rewriting history. In the pursuit of innovation, we stand tall. At COMPUTEX embrace where dreams enthrall. Spark, illuminate digital nights. Yes, yes, yes. Tech titan startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. AI nights. Hey. Innovation spark, illuminate digital nights. Yes, yes, yes. Tech titan startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. Yo, check it, it's the rise of the tech scene. Listen close, AI's the heartbeat. Tech giants, they impose startups on the grind. Chasing their dreams in the realm of innovation. Nothing's as it seems, networking sessions where minds collide. Ideas sparking innovation as our guide. From the product launch to thought leadership stance, we're carving our path, taking every chance. So let's raise our voices in this digital symphony. Tech giants and startups rewriting history. innovation, we stand tall. At COMPUTEX, it's embrace when dreams fall. Spark, illuminate digital nights. Yes, yes, yes. Tech titan startups, forge your paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. AI nights. Hey. Innovation spark, illuminate digital nights. Yes, yes, yes. Tech titan startups, forge your paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. Yo, check it, it's the rise of the tech scene. Listen close, AI's the heartbeat. Tech giants, they impose startups on the grind. Chasing their dreams in the realm of innovation. Nothing's as it seems, networking sessions where minds collide. Ideas sparking innovation as our guide. From the product launch to thought leadership stance, we're carving our path, taking every change. So let's raise our voices in this digital symphony. Tech giants and startups rewriting history. In the pursuit of innovation, we stand tall. At COMPUTEX, it's embrace where dreams fall. Spark, illuminate digital nights. Yes, yes, yes. Tech titan startups, forge your paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. AI nights. Hey. Innovation spark, illuminate digital nights. Yes, yes, yes. Tech titan startups, forge your paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. Yo, check it, it's the rise of the tech scene. Listen close, AI's the heartbeat. Tech giants, they impose startups on the grind. Chasing their dreams in the realm of innovation. Nothing's as it seems, networking sessions where minds collide. Ideas sparking innovation as our guide. From the product launch to thought leadership stance, we're carving our path, taking every change. So let's raise our voices in this digital symphony. Tech giants and startups rewriting history. In the pursuit of innovation, we stand tall. At COMPUTEX, it's embrace where dreams fall. Innovation spark, illuminate digital nights. Yes, yes, yes. Tech titan startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. AI nights. Hey. Innovation spark, illuminate digital nights. Yes, yes, yes. Tech titan startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. Yo, check it, it's the rise of the tech scene. Listen close, AI's the heartbeat. Tech giants, they impose startups on the grind. Chasing their dreams in the realm of innovation. Nothing's as it seems, networking sessions where minds collide. Ideas sparking innovation as our guide. From the product launch to thought leadership stance, we're carving our path, taking every change. So let's raise our voices in this digital symphony. Tech giants and startups rewriting history. In the pursuit of innovation, we stand tall. At COMPUTEX's embrace, where dreams enthrall. Innovation spark, illuminate digital nights. Yes, yes, yes. Tech titan startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. AI nights. Hey. Innovation spark, illuminate digital nights. Yes, yes, yes. Tech titan startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. Yo, check it, it's the rise of the tech scene. Listen close, AI's the heartbeat. Tech giants, they impose startups on the grind. Chasing their dreams in the realm of innovation. Nothing's as it seems, networking sessions where minds collide. Ideas sparking innovation as our guide. From the product launch to thought leadership stance, we're carving our path, taking every change. So let's raise our voices in this digital symphony. Tech giants and startups rewriting history. In the pursuit of innovation, we stand tall. At COMPUTEX's embrace, where dreams enthrall. Innovation spark, illuminate digital nights. Yes, yes, yes. Listen close, AI's the heartbeat. Tech giants, they impose startups on the grind. Chasing their dreams in the realm of innovation. Nothing's as it seems, networking sessions where minds collide. Ideas sparking innovation as our guide. From the product launch to thought leadership stance, we're carving our path, taking every change.
So let's raise our voices in this digital symphony. Tech giants and startups rewriting history. In the pursuit of innovation, we stand tall. At COMPUTEX, this embrace where dreams evolve.
Spark, illuminate digital nights. Yes, yes, yes. Tech titans, startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. Innovation spark, illuminate digital nights. Yes, yes, yes. Tech titans, startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. Yo, check it, it's the rise of the tech scene. Listen close, AI's the heartbeat. Tech giants, they impose startups on the grind. Chasing their dreams in the realm of innovation. Nothing's as it seems, networking sessions where minds collide. Ideas sparking innovation as our guide. From the product launch to thought leadership stance, we're carving our path, taking every change.
So let's raise our voices in this digital symphony. Tech giants and startups rewriting history. In the pursuit of innovation, we stand tall. At COMPUTEX, this embrace where dreams evolve.
Spark, illuminate digital nights. Yes, yes, yes. Tech titans, startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. Innovation spark, illuminate digital nights. Yes, yes, yes. Tech titans, startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. Yo, check it, it's the rise of the tech scene. Listen close, AI's the heartbeat. Tech giants, they impose startups on the grind. Chasing their dreams in the realm of innovation. Nothing's as it seems, networking sessions where minds collide. Ideas sparking innovation as our guide. From the product launch to thought leadership stance, we're carving our path, taking taking every change. So let's raise our voices in this digital symphony. Tech giants and startups rewriting history. In the pursuit of innovation, we stand tall. At COMPUTEX embrace where dreams enthrall. Spark, illuminate digital nights. Yes, yes, yes. Tech titans, startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. AI nights. Hey. Innovation spark, illuminate digital nights. Yes, yes, yes. Tech titans, startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. Yo, check it, it's the rise of the tech scene. Listen close, AI's the heartbeat. Tech giants, they impose startups on the grind. Chasing their dreams in the realm of innovation. Nothing's as it seems, networking sessions where minds collide. Ideas sparking innovation as our guide. From the product launch to thought leadership. In the post-text domain where AI ignites. Hey. Innovation spark, illuminate digital nights. Yes, yes, yes. Tech titans, startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. Yo, check it, it's the rise of the tech scene. Listen close, AI's the heartbeat. Tech giants, they impose startups on the grind. Chasing their dreams in the realm of innovation. Nothing's as it seems, networking sessions where minds collide. Ideas sparking innovation as our guide. From the product launch to thought leadership stance, we're carving our path, taking every change. So let's raise our voices in this digital symphony. Tech giants and startups rewriting history. In the pursuit of innovation, we stand tall. At COMPUTEX embrace where dreams enthrall. Innovation spark, illuminate digital nights. Yes, yes, yes. Tech titans, startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. AI ignites. Hey. Innovation spark, illuminate digital nights. Yes, yes, yes. Tech titans, startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. Yo, check it, it's the rise of the tech scene. their dreams in the realm of innovation. Nothing's as it seems, networking sessions where minds collide. Ideas sparking innovation as our guide. From the product launch to thought leadership stance, we're carving our path, taking every change.
So let's raise our voices in this digital symphony. Tech giants and startups rewriting history. In the pursuit of innovation, we stand tall. At COMPUTEX's embrace, where dreams evolve.
Innovation spark, illuminate digital nights. Yes, yes, yes. Tech titan startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred.
Good afternoon, everyone. Welcome back to the 2024 COMPUTEX Forum. For those of you joining us for the first time, I'm Jeannie Chang, your MC for today. This afternoon, we'll delve deeper into the theme of Behind Generative AI. Let's get started with our first speaker, Mr. Praveen Vaidyanathan, the VP and GM of the COMPUTEX Group, Compute and Networking Business Unit at Micron. Together, we will explore the memory and storage technologies critical to AI's future across data center, edge, and client devices. Before the presentation, let's watch a short video together. Let's welcome Mr. Vaidyanathan.
Thank you. Thank you. Creative, magical, beautiful, inspirational. These are words that we use to describe the core of who we are as humans. These are words that we just used to describe technology. These are words that I will use today to connect humans and technology. I've been thinking about why you're all here today, and I believe that you're all here today to learn something new about technology, something new about products that you didn't know before you came to COMPUTEX this year. I believe you're here to make connections with colleagues, industry leaders, to make connections with friends, some old, and some new, that you will walk away with. I also believe you are here to take away something that you can go back and use in your life at work. I also believe that whatever you do at work with what you take away will fundamentally build better products and will fundamentally change the lives of millions of people in the world. Micron and you have a very shared mission. Micron's mission is to transform how people use information to enrich life for all. My name is Praveen Vaidyanathan, and I am the VP and GM of the Compute Products Group at Micron. And I am here today to share a little bit about memory and storage products that I believe will enable the art of the possible, and sometimes the art of the impossible. We want to build deeper connections with each one of you, our customers, our partners, users, so that we can reimagine how we architect the human-technology connection. Let's talk a little bit about the why of AI. Why is AI all everywhere around us? Why is AI being unleashed in the world? I'm sure all of us can come up with unique examples of our own, but I want to talk about 3 of these. I want to talk about healthcare, I want to talk a little bit about automotive, and I want to talk about what we'll generally call science. Healthcare. I live in San Francisco, and I've lived very close to the hub and the center of the biotechnology industry. There are so many stories that I've heard and I've read about what used to take decades, years to develop new molecules, to develop new drugs, has been accelerated by orders of magnitude with the help of AI, a massive help to humanity. Where I live in San Francisco, it's very common to have self-driving, autonomous taxis. We use these to ride to work. We use these to ride to go meet friends and family. We use these just to avoid the traffic in San Francisco. Science, massive data analytics enabled through machine learning algorithms. Not just analytics, but being able to convert this into intelligent insight that changes our lives is enabled through AI. On a more personal level, I think about languages, and here I am here talking to you, and we are able to communicate and understand each other through the power of language. We also live in a very global world with multilingual personalities and cultures, and we all know the challenges when we cannot communicate in the same language. Natural language processing, LLMs are changing this. Language is no longer a barrier in communication. It enables how we relate to each other. The why of AI should immediately translate into the how. And at the very heart of enabling AI and the how of AI is memory and storage. Let me start with the data center and the cloud applications of AI. If you think about generative AI in the cloud, you think about AI infrastructure in the data center. It's been a big part of lives for the last 2 years. Memory and storage are trying to solve 3 problems in this space: bandwidth, capacity, and power. 30 terabytes of storage per SSD forms the cold storage, warm storage tier of AI infrastructures. Massive amounts of SSDs connected across data centers at the rack level within servers forms the backbone of the massive amounts of data that we are using to develop AI, to train AI models and develop AI inference solutions. When you want this move to this memory, when you want to move this data quickly into your memory, you need high-performance SSDs. Gen 5, Gen 6 SSDs continue to scale the capabilities of this hot storage level. Last week, Micron announced a key milestone in the industry when we released our Compute Express Link memory modules that takes your existing AI infrastructure and allows you to scale the capacity of that infrastructure and give you additional bandwidth. Then we come to the workhorse of the AI infrastructure, with this DDR memory. DDR5 is one of the most versatile solutions when you want to optimize bandwidth, capacity, and storage in your AI infrastructure. Finally, my favorite 3-letter word used to be MOM, my mom, but that was last year. My favorite 3-letter word now, and I will pause for dramatic effect, is HBM. high bandwidth memory. This innovation came to the industry in the mid-2000s, and it has scaled up to become a very important element of any AI infrastructure today. As you move from compute-bound workloads to memory-bound workloads, the bandwidth that comes from high bandwidth memory is absolutely necessary to build AI infrastructure. So I told you what my favorite 3-letter word was. Any guesses what my favorite 5-letter word is? It's HBM3E. Micron was the first to release a 8-high stack, 24 gigabyte HBM3E into the market in July of last year. We now have solutions with 24 gigabyte and 36 gigabyte capacities. The 24 gigabyte is shipping in the market with an amazing speed of more than 1.2 terabytes per second per placement of HBM. Most infrastructures use multiple placements per GPU to scale the bandwidth. A corollary of the HBM3E is DDR5. Micron was again the first to develop, the first to validate on CPUs, and the first to ship to production a monolithic 32 gigabit base DRAM, 128 gigabytes in March of this year. Most server infrastructures couple GPUs with CPUs. CPUs that require 2 to 3 terabytes of memory absolutely require this 128 gigabyte solution, which with our advanced technology provides you over 45% improvement in bit density and is the most TCO efficient way for you to construct an AI server. One of the other things I talked about as a problem we are trying to solve is power. You can scale performance, you can scale bandwidth, but we all know how much we all need to focus at all levels of components and infrastructure on optimizing power. Micron's HBM3E was developed with this in mind. It has over 30% lower power than our competition. That's somebody who actually developed the product, I think. Our DDR5 was with the same thing in mind, using our advanced 1 beta nanometer node, using our 32 gigabit design, over 20% improvement in energy efficiency. Think about what you can do in the data center with this. You can drive lower power consumptions. It lowers your operational costs. You can actually use that power to drive further performance improvements and efficiency gains. This will continue to be a focus for Micron in order to drive power optimization in the industry. And I don't know how many of you know this, but yesterday, June 4th, in the US, was declared National DRAM Day. 56 years back, on June 4th, the first DRAM patent was issued to Robert Dennard and IBM, a very important day in the industry. This is a recognition how DRAM has become a big part of an economic driver in the industry and is driving technological innovation. This week in Taiwan, there's been a lot of conversations about how Taiwan is now at the heart of AI. Micron's HBM3E is stacked, assembled, and built right here in Taiwan. Micron's DDR5 128 gigabyte is manufactured using 1 beta technology wafers right here in Taiwan. We are very proud to be a core part of this ecosystem that is developing in Taiwan. We are very proud to work with the people of Taiwan to bring these innovations to the industry. Generative AI is not just at the edge, not just at the cloud. It is transitioning to devices at the edge, things that we hold in our hands every day. But I will use the term hybrid AI because as we talk more to people, we find out use cases. We realize that this is really a combination of use cases across the cloud and the edge that will really make this most valuable to all of us. The same challenges of power, bandwidth, capacity. The devices I'm talking about are personal computing devices, PCs, tablets, notebooks, laptops that we use every day. Phones in our hands, everybody's got one, bringing AI closer, right in the palm of your hand. Automotive, self-driving cars, the massive amounts of compute, memory and storage that goes into a car to drive real-time decisions, to drive better, safe driving, is something that's going to be driving our choices on what cars we buy, which cars we drive, or maybe which cars we don't drive, just cars we get into. This week in COMPUTEX, there's been a lot of information coming to us about what are AI PCs. PCs are central to COMPUTEX, and AI PCs has become central to COMPUTEX this year. There's lots of conversations on top CPUs and NPUs. How many TOPS do you need? How much memory do you need? How much storage do you need? Announcements by a lot of our partners on 45 TOPS, 48 TOPS, 50 TOPS, maybe 120 TOPS soon. But as this improves, we are working very closely with our partners to ensure that the right memory and storage solution is right there. It's designed to enable compute workloads and memory workloads. So I want to talk a little bit about the products that we are building in this space. And I'll talk about 3 specific products. The first is the Micron 3500 NVMe SSD. Oh, sorry. Did this go to the right one? No, it didn't. OK. The first is the Micron 3500 NVMe SSD. So this is an interesting product. This is a Gen 4 product. It will fully saturate a Gen 4 PCIe bus. When we designed this product and we released it in December of last year, we took careful attention to develop firmware, to tune the firmware based on workloads that the SSD operates in the AI environment. A lot of you in this room are technologists. You work in storage. You work in compute. You are familiar with the benchmark called SpecWPC, which really looks at very optimized workloads for very specific applications. And I'll take science as an example, life sciences. The optimization that we did at the firmware level on this product drove over 132% improved performance compared to all the SSDs in this class of products at that time. That's the kind of work that we need to be doing as a memory and storage, and we'll continue to do to ensure that we deliver the best products to the industry. Before I talk about the next product, I maybe want to spend a little bit on the history of PCs. Late 70s was the PC revolution. Since then, a lot of different memory solutions have been coming out, single inline memory modules, different kinds of DDR. In 1997, the most ubiquitous, commonly used form factor in PCs, small outline dual inline memory modules, which a lot of us very fondly call SODIMMs, was released. And it's been a workhorse for the industry since then. But there haven't been any major innovations in memory form factors for PCs till 2024. Collaborating with our partners and the industry, we released what is called an LPCAMM2, which is a new form factor. We were the first to bring it to the market in January of this year. And one of our key OEM partners actually has this in a laptop released in the market in April of this year. LPCAMM2 is a low-power memory-based modular solution. It's called a compression-attached memory module. And it drives some pretty significant value in a PC. I talked about 3 problems we're trying to solve, right? Bandwidth, capacity, power. In PCs, there's one more area that is important: form factor and modularity. This product today, as it's released, the LPCAMM2, gives you an over 50% bandwidth improvement for a DDR5-based SODIMM available at the same time. It's a dual-channel 128-bit module that drives much better performance in a system. It will provide over 60% lower power in active use cases and over 80% lower power in standby use cases. We talked about how power is so important. AI PCs are hungry for performance, hungry for capacity, but we cannot increase power. This form factor is going to be a key part of how AI PCs evolve. In fact, we believe that this will be the primary solution as AI PCs scale to higher and higher performance over the next several years. The other thing that is important, I said, is space. This product is 60% smaller than the equivalent SODIMM of the same capacity and same bus width. massive opportunity to innovate the motherboards and the PC design. I've been sharing a lot of my favorite things with you today. 2 more favorite things. My favorite music album is Led Zeppelin 3. My favorite graphics memory is GDDR7. Today at COMPUTEX with you, we are announcing for the first time and introducing this product. We are sampling the industry's fastest graphics memory, GDDR7, a new standard today with our customers. Think of graphics memory for 2 key applications. Think of it as gaming and think of it as AI. The advent of ray tracing in gaming, resolutions going from 1080p to 4K and 5K and beyond, motion capture technology in gaming, the introduction of non-player character behaviors with AI in gaming, all this is driving higher and higher bandwidth requirements. GDDR7 will be launching today with a speed capability of up to 32 gigabits per second, which means at a system, you're talking about 1.5 terabytes per second of bandwidth, more than 60% higher on the previous generation GDDR6. Power is very important. Micron's GDDR7 has a 50% improvements in power efficiency compared to the previous generation GDDR6. Our innovations on a 1-beta DRAM technology, our design innovations, allow us to record the highest bit density GDDR ever available in the market, GDDR7. We were pioneers in introducing what you all would recognize as PAM4 technology with the previous GDDR product. This uses an I/O interface based on PAM3 technology, driven by some of our experiences where we've been able to innovate with this product. These are the 3 products I'd like you to take away and think about as you all think about how you want to architect your next PC solutions. I want to leave you with a view of the entire Micron product portfolio developed for AI across all the applications of data center, PCs, mobile phones, and automotive. As I close out, I want to go back to where we started, about the connections between technology and humans. Some of us, maybe not all of us, grew up reading the thoughts and words of one of the most imaginative people of our generation, Isaac Asimov. Asimov talks about technology, he calls it science, but he says science accumulates knowledge, humanity accumulates wisdom. We have an opportunity to bring technology and humans, knowledge and wisdom closer together through AI. Let's strive to use AI to deepen the connections between us and our connection to the world around us. Thank you for spending your afternoon with Micron.
Thank you, Mr. Vaidyanathan, for your wonderful sharing. Next, we will hear from Mr. Eddie Ramirez, the Vice President of Marketing Infrastructure line of business at ARM, who will discuss the industry transformation that will define the future of data center and computing in the age of AI. Let's welcome Mr. Ramirez to the stage.
Good afternoon, everyone. It's great to be here. Great to be back in Taipei City. And for this 1 week, this is the capital of AI. For me, it's great to be back because this is my 10th COMPUTEX. I was just thinking back as to that. So it's a great milestone for me. And this is the most exciting COMPUTEX I've been to. The energy, the excitement, all the announcements that we're seeing here today, all of them because of generative AI. Generative AI has captivated the tech landscape. And what I'm going to talk to you about is very simple. The transformation that's happening in the data centers to help support and scale generative AI workloads. So I'll start by talking about what's probably obvious to everyone. It feels like AI is everywhere. It's been in every keynote. Every product seems to be about AI of some capacity. Every chip seems to be AI accelerated. And the reason that we're seeing such energy and excitement around AI, probably just so different from any other technology, is because the gains that AI will bring to us are real. We can start to see them today. And it's not just because we download ChatGPT and can find information faster, or it's not because we're generating images that help us be more creative. It's really because the tools are going to be helping us with productivity. They're productivity multipliers. I think about software developers, if some of you are in the audience today. 30% of software is written with AI-assisted tools, like GitHub's Copilot. That just means that people can work faster, smarter, and get more things done. That is why people are excited about Gen AI. But it's not just the tech industry that's looking at Gen AI for productivity gains. A survey that was done by MIT Research found that 50% of large companies already have AI projects underway. And it's most prevalent in industries like retail, healthcare, professional services, and manufacturing. And the reason that it's becoming so prevalent so quickly is because small teams of software developers can utilize open source models and ML frameworks to deploy very quickly powerful applications, applications that unlock the data that many of these companies had hidden away in different departments. A second metric that just shows the promise of AI is around how much investment we're seeing in AI startups and enterprises. Last year alone, there was over $50 billion invested in AI companies. It's a tremendous amount, and it's showing that the financial community is also betting on the fact that AI is going to unleash productivity gains and be the next driver of economic growth. A third stat that I wanted to call out was actually something that I read that Mr. Liu pointed out last year, the chairman of Foxconn. He estimated that AI servers, which is the fastest growing server class product in the market today, would go from 30 billion USD to 150 billion USD in a few short years. Now, this probably gets a lot of people in this room excited because Taiwan is responsible for 80 to 90% of all the servers shipped in the world. So who better to know and predict what AI is going to do for the data center market than Mr. Liu? Now, all of this growth and the potential opportunity that it represents is why a lot of us are so excited here at COMPUTEX. How can we play a role? And how can our businesses help and be helped by this AI wave? So it's a great opportunity, but there's also a challenge that AI represents. All this insatiable demand for AI has exposed the fact that AI computing is both expensive and power hungry. And so there's a growing concern that's emerging that we need to do something different. We need to look at ways of transforming the way that we deliver computing for AI workloads and be able to develop infrastructure that can both scale, but do so without emitting tons of carbon. And so just to give you an example of the problem and the potential that we face, I wanted to use some data from our friends at Hugging Face and Carnegie Mellon University looked at many of the common AI tasks. And what they found is that the amount of energy for inference of these tasks is growing exponentially as AI tasks become more complex. So if you take, for example, text generation, which is really at the heart of chatbots, and you look at the inference energy alone, not including training the models, just the inference energy alone, and you scale that across a large number of users. Trias Research estimated that very shortly we'll need over 10 trillion tokens generated to support chatbot usage. That will require 47 billion kilowatts of energy. That is over 2 times the amount of energy consumed by all of Google's data centers today. And that's just chatbots alone. As we start getting to more immersive large language models, multimodal models, models that speak to you, create images, or even create videos, there just isn't enough energy to power the data centers that need to drive all of this computing. And so the cloud providers themselves are actually starting to think in a different way of how they build out their AI data centers of tomorrow. Arm has been working with many of the top companies, including Nvidia, AWS, Microsoft, and Google, to define new ways of driving AI compute. And at the heart of that, these companies are leveraging Arm's Neoverse platform to build custom silicon solutions. They're not just using off-the-shelf solutions or relying on one partner. They're actually now building their own silicon, whether it's AI accelerators or general purpose server products, or even networking infrastructure, DPUs, and networking accelerators. All of these are driving increased scale in performance and power efficiency. I talked about the Google data centers. The most recent cloud provider to make an announcement about their ARM-based silicon projects was actually Google. Just in April, they announced the Axion CPU. The Axion CPU delivers 50% better performance and 60% better power efficiency than any other processor in the Google fleet today. That's why these companies are working with Arm to deliver custom silicon. Now, in the AI data center of tomorrow, there's going to be both CPUs and AI accelerators like GPUs that are powering inference tasks. They'll coexist. I think about this as an analogy of cars and buses. Depending on the size of the model, GPUs offer very great performance and TCO. As the models get larger, 100 billion parameter models, then GPUs are an effective tool, but they're also more expensive. You wouldn't use a bus if you're only transporting 5 or 6 people. It would just not be cost efficient. And so at Arm, we've been working on trying to improve the performance of CPU inference. And particularly for the 5 to 10 billion parameter models, what we have found in our data is that on-CPU inference offers a tremendous TCO equation. In fact, our Neoverse V1 processors, when we are actually testing cloud instances with Neoverse V1, with Llama 2's 7 billion parameter model, delivers 64% TCO gains over the A100. And that's because of the entirety difference in cost structure. 11x more cost effective to run LLM inference. Our Neoverse V2, our latest generation of data center processor, is delivering 132% TCO gains versus the H100. And TCO as measured by the amount of tokens per second per dollar. And so Arm is working to deliver the software experience that offers an optimized experience to developers. And at this year's COMPUTEX, we announced ARM Kleidi AI. ARM Kleidi AI is a set of libraries that are optimized to run Gen AI inference on a variety of ARM cores. One library pre-integrated into many of the most popular frameworks so that you can get an out-of-the-box experience that is optimized for on-CPU inference. And so the results that I shared with you, if it surprised some of you, are because of using Kleidi AI. And so now the benefit of this approach is that you can effectively run something like Llama 3, which was just released weeks ago. You can run it in the cloud on AWS's Graviton 3 processors and experience 2 to 3 higher tokens per dollar than you can with x86-based instances. You can also take the same Llama 3 code and run it on even a Raspberry Pi at the edge. The ability to have an optimized experience, both in the cloud and at the edge, will simplify the life for developers. It'll allow them to write their applications for multiple environments. And the impact is going to be significant. ARM devices number over 30 billion devices every year are in the market, many of those at the edge, can now be engines for large language model and generative AI computing. And it's not just large language models that run well on ARM. In fact, for ARM Neoverse, we have worked diligently to provide generation-to-generation performance improvement. In fact, now, our Neoverse V2 processor exceeds the performance of any 86 processor in the market by a significant amount for the most popular workloads. This includes SQL databases, enterprise Java, and AI workloads like XGBoost. And so that's why we are seeing a lot of ODM partners here in Taiwan and OEMs across the world adopting ARM platforms, not just in the cloud, but also for the enterprise data center. They're utilizing CPUs from our partners Nvidia and Ampere to drive the same performance and power efficiency gains that the big hyperscalers are seeing with their custom silicon. And there's one more transformation that is underway. And this is the transformation for really large-scale Gen AI models. I'm talking about 50, 100 billion parameter models. The transformation that's going underway is that they are also taking advantage of custom silicon and unique accelerators. There are over 80 companies currently building some type of AI accelerator. These companies want to take advantage of architectures like Grace Hopper that closely couple ARM-based CPUs with their accelerators. And so last year, here at COMPUTEX, we debuted our ARM Neoverse compute subsystems. These are pre-integrated ARM IP, taking a best-in-class design and taking it all the way out to full validation, so that we're given effectively a building block for people to use to still build custom solutions. It's saving our customers tremendous time, money, and allowing them to build a broader, diverse set of solutions. We have customers who have cut their design time in half. And so we took our Neoverse and this year announced our Neoverse N3 and V3 platforms, NCSS. And we made them chiplet ready so that chiplets are going to enable these products to be able to combine with other accelerators. And the most popular design point right now is AI accelerators combined with our Neoverse CSS. The benefits of chiplet are significant. Chiplets allow you to take very large designs and compose them with pre-built components. You can have a compute chiplet, an I/O chiplet, an accelerator chiplet, and now you can combine those together in 2.5D or 3D technology to give you reduced cost, better performance, better yields, and in many cases, allow you to expand the amount of SKUs that you're creating. There are some challenges to getting a chiplet ecosystem fully up and running. And that's why ARM has been working collaboratively with partners in the industry to develop standards like ARM chiplet system architecture. These are able to give recipes and guidelines for how to build chiplet designs, for how to manage composability, security, management features of these designs. We also have taken our latest AMBA protocol, AMBA-Chai protocol, and enhanced it for chiplets. This protocol now allows our partners to effectively have full coherency between the compute chiplet and the accelerator chiplet. So an accelerator chiplet can talk to the DDR on the compute chiplet. The compute chiplet can talk to the HBM on the accelerator chiplet, potentially reducing one of the more expensive components in AI server design, which is the memory, by using it more effectively. We're also working very closely with the UCIe consortium. ARM is a board member. We chose to do so that we can help proliferate a standard interconnect interface. We take these ingredients, and that's one way to help a chiplet ecosystem. But we felt we needed to do more. And so last year, we introduced ARM Total Design. We reached out to partners across the semiconductor industry to help speed up and deliver custom silicon to more people. Our idea was simple. Can we democratize compute? Can we bring more partners, including partners from here in Taiwan, to be able to deploy AI solutions for the next-gen data center? And I'm really excited to announce that in a few short months, some of the work that we've been doing with local tech leaders here in Taiwan. Novatech, one of the largest semiconductor shipment companies here in Taiwan, known for display products, is able to leverage our Neoverse CSS platform, combine it with AI accelerators, using TSMC's CoWoS packaging technology and high bandwidth memory, and is now working to deliver a powerful solution for Gen AI computing. It shows how they can expand into new markets very quickly because of our Neoverse CSS platform. Realtek, another partner which is known for bringing network and connectivity to IoT devices and endpoints, is leveraging our Neoverse CSS products to deliver compute together with networking for the next generation of DPU products. And they're doing this with ARM and with the broader ARM Total Design ecosystem. And this year, at this event, I take great pleasure in announcing our newest partner in ARM Total Design, MediaTek, the largest semiconductor company here in Taiwan. MediaTek is known for their cutting-edge IC designs, technology that they've developed around power efficiency as they've become a leader in the mobile space and the client notebook space. The same technology leadership and the cutting-edge design that they're applying together with ARM Neoverse CSS is going to bring even greater amount of solutions to the generative AI marketplace. So we're very excited by the collaboration that we're announcing here today. And so ARM Total Design has grown to 25 partners in just under 10 months since the program has launched. We have all the leading foundries in ARM Total Design. We have ASIC design partners from all over the world who are now working and building expertise in helping partners deploy custom silicon solutions rapidly. And we're working with several third-party IP vendors to align our roadmaps and pre-integrate our technologies. And firmware partners like AMI are now delivering full-feature firmware for these products. So as you can see, end-to-end partnerships to deliver silicon based on Neoverse CSS. No other ecosystem has this level of diversity in its supply chain. And it's because it's within Arm's DNA to help our partners get into new markets and be able to bring their technologies and their ideas to life. And so that's why Arm leverages not only its technology, its power-efficient designs, its software optimization work. It's all of these things that help bring and transform computing. We've done it for mobile phones. We've done it for IoT devices. And now we're doing it in the data center. And I want to thank all the partners here in Taiwan who are helping us make this happen and bring together a more power-efficient data center so that we can all benefit from generative AI use and not have to worry about the power consumption constraints of the data centers of tomorrow. That's why we say the future of compute is built with Arm, and the future of AI is also built with Arm. Thank you.
Thank you, Mr. Ramirez, for the amazing insight. Now, let's move on to our next speaker, Ms. Rosalina Hu, the Global Vice President of Brand Strategy at Seagate, a leader in hard drive innovation. She will discuss the demands of the AI era. Welcome, Ms. Hu. The floor is yours.
大家好. I'm so happy to be here in COMPUTEX, and I'm Rose Hu. I manage the global brand strategy for Seagate Technology. And I'm here to share with you how AI storage, specifically hard drive, shape the AI future. And before I do that, because I can, I want to actually say this. I want to celebrate all the female in the tech industry in this room. So give it applause. Keep growing and keep believing in your career. So, you and I are living in an amazing time. This is the time of the biggest disruption, potentially, in the humankind history. And this kind of a moment had happened before in the past. It's comparable to, if you look at the history of invention, steam engine, accelerating the global industrialization, the personal computer, the internet, the smartphone. It accelerated information sharing and gathering, and also share how we interact with each other, how we learn, and how we do business. And Gen AI potentially can do that big of a transformation or even bigger. It will change the fabric of our life. Now, with the past innovation, it has connection to data. But Gen AI is rooted in lots of data. You heard from the other speakers about trillions of token, parameter, et cetera. Those are data. And data fuel AI. And AI requires more data to make it better. And AI also will fuel data generation, new data generation. And this new data generated by AI, the Gen AI specifically, will need to be grounded with that original data that are being trained as the source of truth, meaning that data really becomes so valuable than ever in this AI era. And storage is super critical to preserve the data for AI. According to the IDC, the global known analysts, they're predicting that by 2028, there's going to be about 394 zettabytes of data. It's a lot of data. And they already included some prediction of Gen AI in here. It essentially doubled in size in 5 years. This forecast, however, is actually understated because it does not include yet the potential of multimodality LLM or what we typically call also the vision model, because it's really hard to predict. We're still in the very beginning of this vision model, and as it goes ubiquitous, the growth rate maybe become more than what we expected. Gen AI is truly a data creation force multiplier. The prediction from Gen AI alone, it will create about 100 zettabytes of data in 4 years. So if you remember the number in the previous slide, that's approximately about 25%. But again, it's understated. And some sources say it's about 170 to 200% CAGR for Gen AI to generate data. That's actually significantly more than when the era of smartphone and PC in terms of data generation. And why is it that big? Number one, it's that richer content. With the multimodality Gen AI that involves image and video, no surprise, the data size is huge. So then most likely, the data that's going to be replicated also going to get bigger. And we need this replication because in order for all this new generated data from image and video to be used, it needs to get closer and closer to wherever the use cases are or the users are. So more replication is going to be needed. And additionally, we believe that more retention is needed for the data. I mentioned about the source of truth. If you hear or read some of the recent news, AI can hallucinate. It's not something that we need to be negative about. It's just something that we need to go through as the technology getting mature. But it is concerning if there's no source of truth. One of the funny examples that I remember is the Gemini, when it's being asked about who are the founding fathers of America, it was highly, highly more biased towards diversity answers, which is completely wrong. And if we don't preserve our historical information, then most likely the distortion of truth can happen years after. So it is critical to actually retain source of truth of data. And the governments all over the countries and the world requiring also data retention policy. So we believe with Gen AI that retention policy is going to get longer, and it could be indefinitely. So the conclusion here is that it's just going to be more exabytes that we have to deal with in the world. So for every technology that are introduced in the human mankind, there's the adoption that's called the S-curve. And Gen AI is actually following this S-curve too, and it actually accelerates. And we believe that when it gets to the mass adoption, the critical thing that everyone has to be prepared for is that scale of storage demand. Now, there are technically 4 stages here, and let me just go through quickly the stages. The first 2 stages, essentially where today we are now, it's about building and training the model, and then also deploying the model and creating application on top of these models. It's a lot of excitement. A lot of the startups are actually proliferating in every country, trying to build new application. And then after that is the early adoption of those applications, and then the mass adoption is going to happen. And this is where the storage is going to take off. But in each of these phases, technically even the first 2 phases, storage are critical too. And you can think about all the data that needed, like I mentioned, to train. It required that data lake to support it. And most likely it's using the existing capacity of storage. However, with the vision model, we believe that more and more of this data lake is going to have to grow. Even the existing capacity will not be enough. For AI to reach full potential for consumer and businesses, it does need to be deployed everywhere. At the cloud or the core, at the edges, which is typically an on-prem or co-location, and also at the endpoint, where the consumers are using the application. So cloud is where the foundational large language model are being stored and trained, but you also heard lots of the announcement from Intel, AMD, Nvidia about NPU that will enable compute for AI PC and AI workstation, and also Qualcomm Snapdragon for mobile AI compute. With all this multimodality, large language model development, the data size is going to get bigger, and that means also in each of this deployment state, we will need mass storage capacity at the cloud, the edge, and the endpoint. So as AI going everywhere, storage will also be everywhere. So it is not enough for company or any company that are data intensive to think only about compute and networking requirement to be AI ready. Storage is the backbone for data preservation that is needed for AI. Existing storage capacity will not be sufficient, so enterprise will need to be strategic to plan ahead for that storage growth as the mass deployment going to happen. So data centers must quickly also increase storage capacity. And they have to balance these two forces going against each other, the explosive data creation and resource scarcity. The explosive data creation competes against the resource capacity constantly. And let me go through the resource scarcity that are mentioned here. Real estate. I think you heard from everyone already how data centers are growing like crazy. It's the hottest asset because of AI. I read an article that says that the availability of co-location and data center in Singapore, Tokyo, and Hong Kong is below 2%. And all the companies are growing their data centers and looking for land, and it jack up the price of real estate. The CAGR of data centers globally is about 10%. However, the hyperscalers grow at 20% rate. So everyone is competing. The co-location space essentially is very competitive in terms of prices, and the cost to build data center is also growing up to $1.5 billion US. Second is the power. It is very energy hungry. I think everyone before me already mentioned this as well. It's about 160% more power demand AI is going to need by 2030. And considering one gen AI, images being generated, it takes about the same as the energy of one fully charged smartphone. So yes, we do need to figure out how this power issue is going to be. Now, when it comes to storage decision, besides the sustainability aspect, is the budget. There is a TCO, the terms of total cost optimization for storage decision process. And that is acquisition of the devices, the power, and other costs. But the largest cost out of the three is actually acquisition of the devices. So how do enterprises and hyperscalers decide on this? Now, let's use hyperscalers because they are the post child as an example of the best in terms of TCO optimization. So I'll let you know the secret. It is not SSD that they use the most. It's actually 90% of their data they store in hard drive. And why is that? Because of the TCO of the acquisition cost of hard drive. It's 6:1. It will forever be 6:1 ratio for SSD for the foreseeable future. So given that, hard drive is a fundamental component for cloud storage and any data center that needs to scale out for Gen AI. With that, we do need to innovate and figure out how to support them. So hard drive areal density is the key to support the key challenges of AI, data center, and AI storage. How do we increase the capacity of hard drive? Technically, there are two ways here. The easy way to think about it is that in the same form factor, with the current PMR, or perpendicular magnetic recording, you can add more platter. At the maximum right now, there's only 10 platter or 10 disks inside the hard drive. You can add 11 platter to increase the capacity. It sounds simple. However, it actually adds more cost to the materials, and it also increases the operating costs, power consumption, as well as resource usage. And the other way is the most sophisticated one and not easy to get to, is to actually pack more bits in the same materials of the form factor that we have. And this is the most sustainable solution, and it actually helped the company to lower the power consumption as well. So Seagate, in early of this year, had introduced Mosaic 3 Plus platform. This is the highest areal density you can achieve in hard drive industry right now. The areal density that we had achieved is 3 terabyte per disk, which is far more compared to the past platform, which is around 2 to 2.4 terabyte per disk. Mosaic 3 Plus is a composite of the most complex nanoscale recording technologies and material science breakthroughs on the industry. It is as complicated or even more with the semiconductor industry. It is our decades of R&D to achieve this density and is extensible beyond 3 TB per disk. More bits are packed in the same form factor 3.5-inch hard drive, no additional platter or head. It's compatible with existing system configuration, so it's easy to deploy and transition for any data centers. So what is the value of areal density increase? It's simply scale again, TCO optimization, and sustainability. And let me quickly go through that. The impact of areal density at scale is profound. Think about this example. If a data center, on average, they have a fleet of 16 terabyte in their data centers racks, and they upgrade it to 30 terabyte, which is basically our 3 TB per disk platform, Mosaic 3 Plus, it essentially delivers double the capacity of storage in the same data center with the same floor space. And what about the power? With the same scenario from 16 terabyte upgrade to 30 terabyte, they will see at least 45% plus power savings. You can see the difference of the number here. The 16 terabyte consume about 0.59 watt per terabyte, whereas the Mosaic 3 Plus consume about 0.32 watt per terabyte. So roughly, it's about 45%. And we also observe greater than 55% embodied carbon reduction, and it's great for the sustainability aspect. So it's about storing more without increasing consumption of space, power, and natural resources. Additionally, the new platform, it was made with 28% less of recycled material by weight, and that also reduces the packaging and shipping impact. Areal density is truly an enabler for a sustainable data sphere and circular economy. The areal density breakthrough is not just what you see with what we introduced, Mosaic 3 Plus. Tomorrow's advancement is already here now. In our roadmap, in our lab, we already achieved the 4 terabyte per disk and 5 terabyte per disk density. We have the prototypes, and we believe that we can deliver 50 terabyte drives by 2028. So that's about doubling the capacity for every 4 years. In the world of AI, data upholds AI, and storage, hard drive, upholds data. Hard drive areal density technology breakthrough is super critical for AI storage to scale and to be sustained. It is where we believe the future of AI is read and written. Thank you, and we hope to see you in the 4th floor.
Thank you, Ms. Yu, for showing us where the future is being read and written. Up next, we have Mr. Jeff Vitek, the Chief Product Officer of Ampere. He will highlight the benefits of using cloud-native processors to deliver more efficient computing for demanding workloads and services. Mr. Vitek, the floor is yours.
Thank you. It's a real privilege to be here talking with everybody today. And looking around and being here for the last couple of days, I see lots and lots of our key partners. And I'm really reminded that those broad industry partnerships are really what fosters innovation, and the heart of that innovation is here in Taipei. Today, we're at a massive inflection point within the industry, and the decisions that we make now are going to shape the next decade and beyond of computing. Power consumption remains the most critical constraint to continued expansion of compute today. With emerging workloads like generative AI, that problem has only become more severe over the last year. The industry needs broad solutions that meet those compute demands, but do so in a sustainable manner. Horizontal innovation has really been at the heart of our industry for the last several decades. Drawing the best of our ecosystem partners, pulling them together into broad solutions that can be deployable across the market has been what has fueled the innovation that we've seen within the data center space over the last couple of decades. It's critical that we continue to come together as an industry and build those types of solutions. The solutions that we build to meet growing compute demands for AI must be accessible to all. Hardware that's available to all users, and also that's deployable in all existing data centers. So it's critical that we build broad, sustainable solutions. As we look at the increase in power consumption within our data centers today, you can see where the tipping point is beginning to occur. Recent studies from the International Energy Agency show that the power consumption by data centers in the United States was roughly 4% in 2022. That could rise as high as 6% by 2026 if we don't make critical changes in the way that we deploy compute. And that's not a problem only in the US. If you look at Ireland, a key place where data centers are deployed today, 17% of Ireland's power is being consumed by data centers. That's as much, if not more, power than is consumed by all urban residential buildings in the entire country. And with the rising demand of compute, estimates are that that could double over the next 4 years, and Ireland could consume as much as 32% of their power from data centers alone. Globally, we already consume 460 terawatt hours of power across data centers worldwide. That could increase to as much as 1,050 terawatt hours by 2026. That's a 2.3 increase. 1,050 terawatt hours represents the entire energy consumption of the country of Japan. So clearly, there's no time to lose. A good example of the types of increases in power consumption that will be brought about by really cool AI applications are in search. Today, a typical traditional search takes about 0.3 watt hours to run. Adding in new generative AI approaches could increase the power consumption of a single search to 2.9 watt hours. This really emphasizes how important it is that we quickly take action and build efficient solutions for AI. It's also important because as the AI attention starts to move from the training phase to the inferencing phase, many of the solutions that are deployed for AI training are complete overkill in the inferencing space. So we need new solutions that are tailored to the problems that we're trying to solve. And if you look at the data centers in general, there are other challenges. Rising operating costs. Space and power are even more of a premium than ever. Software licenses have gotten more expensive. Labor, overhead costs continue to increase. Power isn't only a problem in terms of the grid capacity. Most data centers provision their racks at less than 15 kilowatts. The average rack is about 10 kilowatts. So solutions that demand 50, 100 kilowatts simply aren't deployable in these regions. And we cannot have a solution that is limited to only specific regions that are willing to sacrifice their scarce power to run compute. Also, legacy infrastructure is aging. Lots of legacy infrastructure runs at very low utilization. It's expensive to keep it up, and it's increasingly susceptible to security vulnerabilities. So now is the time to take action, refresh those aging legacy servers, reclaim that budget, that space, that power, repurpose to a new approach to cloud-native computing, to AI computing, and reinvest in innovation and sustainability. It's not the time to continue to do the same things that we've been doing using legacy CPUs that continually increase in power, 500 watts or beyond, GPUs that increasingly consume 1 kilowatt or more. It's time for a different approach. And again, that approach needs to be one that is broadly accessible to all. It can't be limited just to companies that have billions of dollars to spend to build their own hardware. It needs to be deployable across the entire ecosystem. So let me tell you a little bit about what Ampere is doing and what we're doing across the ecosystem to create this change. We started about 4 years ago with our Ampere Ultra family processor. We launched that with 80 cores, increased the core count to 128 the next year. And today, our Ampere Ultra family processors are broadly available. There are over 20 different cloud providers that have instances based on the Ampere Ultra family. There are over 50 OEM and ODM platforms that run Ampere Ultra family processors. So it's never been easier to get access to this new disruptive technology. Last year, we launched our Ampere 1 family, and we started ramping into large hyperscalers like Oracle and Google. And just a couple of months ago, we talked more about future advancements in our roadmap. So we start with our 192-core Ampere 1 family CPU that's available today. We're adding additional platforms throughout the year. Memory bandwidth is becoming an even larger need as we run larger and larger Gen AI models. Our 12-channel platform will be available later this year, and then we'll add a 256-core CPU next year into that same platform. So exceptional power efficiency, exceptional performance, massive core counts, platforms that are extraordinarily flexible and scalable. This is running on TSMC N3, so running at leading-edge nodes. And it sits in the same exact air-cooled environments that the existing Ampere 1 family processors sit in today. So easily deployable in any existing data centers, doesn't require a massive retrofit to accommodate these new, extraordinarily dense CPUs. The Ampere 1 family features our Ampere custom cores. The 192 cores have been optimized from the microarchitecture to the features for today's cloud environments to deliver exceptional scalability, exceptional efficiency, and it includes features that are increasingly important in these types of multi-tenant environments that run at massive scale. Features like QoS enforcement that allow customers to maintain a predictable level of performance even when there are many noisy neighbors competing for shared resources. Features like memory tagging that help to provide memory safety, both from a security perspective as well as protecting against bad pointers in code. These cores feature up to 2 megs or 2 megs of private cache per core, so a massive amount of cache in order to service those data-intense workloads that are common today. On the AI front, native support for bfloat 16, in addition to int8, fp16, and the common formats that are used in AI modeling today. And that's not where we, that's not all. You can see there we have many, we've other products planned in the future. Our platform is extraordinarily flexible. We'll be able to scale to increasingly higher core counts, greater efficiency as we move forward into the future. Taking a look then at the performance that's being delivered by these processors. With our 192-core Ampere 1 CPU today, we're delivering 50% better performance per watt versus AMD Genoa. And when you look at how that scales out at the rack level, we can deliver up to 34% better performance per rack versus AMD Genoa on a benchmark like SpecInt rate, using open source compilers that are accessible to everybody. But it's not just about benchmarks, it's about real-life performance. So what is it that you can do with Ampere 1 processors that's unique? You can run, say, a containerized web service using common components like Nginx as a front-end web server, Redis as a key value store, Memcached as a caching layer, MySQL as a back-end database. The advantage here is that you can deliver not just 34% more performance per rack, but up to 58% more performance per rack amongst these components. If you put all these components together into one integrated service, you can deliver the same performance as AMD Genoa, but use 33% less space, consume 15% fewer servers, and also consume 35% less power. So this helps you to create a much, much more economical and more efficient solution in the cloud. Now, I wanted to also start to show you some of the real platforms that are based on Ampere 1 and talk a little bit about where you can get access to Ampere 1. So Oracle has been deploying Ampere processors for several years. Recently, they've been using their A1 instances that are based on the Ampere Ultra family on a variety of different large language models. Llama 2, Llama 3, Mistral, Orcas, and they've been seeing exceptional performance. It provides a much more efficient solution, much more cost-effective solution for their end users, and they've made those A1 VMs available as a flexible shape for free for 3 months for users to try to run inferencing on. And what I'm really excited about is that Oracle, I can announce today, is in production with Ampere 1, limited availability in the first region, starting in the US. So you can get access now to their A2 instances that are based on the Ampere 1 CPUs, and starting in the US, and it'll expand out across more regions over the next month. There's been a number of large customers that have been running on Ampere 1 at Oracle over the past year. So if you're interested now in starting to test, contact OCI. You can start to get up and running now. So really, really cool to see that broadly available now and out there in the wild. Now, I think everyone here likes hardware. So I thought I'd show off some of the really cool hardware that we have that features Ampere 1. So we have a couple of different servers here from a variety of different OEMs and ODMs. Let me start with, we've got the Supermicro platform right here. So this is Supermicro. This is the Mega DC super server that they have. Let's see if I can, well, we'll leave it closed for now. But we've got this. This features Ampere 1, 192 cores. It's a 2U rack mount server, and it delivers amazing efficiency in that 192 cores. A number of different manageability options with that server, including OpenBMC. So lots and lots of flexibility with a platform like this from Supermicro that has our Ampere 1 CPUs in it. Now they've taken that and extended out the platform. There's also a great shallow depth server as well from Supermicro. This one is a really good fit for the edge, for telco. In this type of a platform, you could get 192 cores down at about a 200-watt footprint. So extraordinarily power efficient for those types of high-performance edge and telco applications. And then we also have an Ampere 1 server from Gigabyte here, from Giga Computing. So this is Giga Computing's Ampere 1 server, also features 192 cores, very, very configurable from a PCI perspective. PCIe Gen 5 features several OCP 3.0 slots in here as well. So really, really configurable platform. Another great data center platform there. So lots and lots of hardware now that's showing up that'll be available that has our 192 core Ampere 1 CPUs in it. We also have platforms from BYD. BYD announced last week their new Reach platform, and it features Ampere 1 platforms in a number of different configurations. So you're going to start to see a lot of platforms showing up with our 192 core Ampere 1 CPUs in it. So really, really exciting, and really excited to have people get their hands on some real hardware that's running this really, really cool technology that we have. So I showed you some of the workloads, web workloads, database workloads, the performance of those on Ampere 1. But as we know, AI has become incredibly pervasive. And AI inferencing is really becoming the most important piece of AI. Roughly 85% of all of the compute cycles within AI will be inferencing. Today, most of the focus has been on training because that's the first step. First step is to train your model, and that's a very unique task. Training a model might take days, weeks, months. It's a massive task, and it's all you're running across a cluster. So it looks a lot more like a HPC or supercomputer type task. And so building a dedicated cluster to train your model can make a lot of sense. Inferencing, though, is very different. Inferencing is really a mixed workload. It is one workload that you're probably running in the midst of many others. Maybe you're running a chatbot. Well, that chatbot has some sort of AI inferencing task that's running behind it, but there's probably also a web application. There's some sort of a web server. There's other databases that are attached. And when you look at that full spectrum of other associated tasks that are required to be run in addition to AI inferencing, that makes up that full spectrum of what we call AI compute. And that's why it's incredibly important to have a flexible, efficient solution for that 85% of the AI task, the AI inferencing space. So here's a great example of some large language models that are running on Ampere CPUs. This is an example from OCI. I mentioned that they've been running a bunch of different large language models on our Ampere processors. So here's a good example. So a lot of times a user might default to, say, running an Nvidia A10 GPU, because maybe they used something similar to that when they were training their model. The example here, you could use an Nvidia A10 card, rent an instance from OCI. It would cost you about $7 to generate 1 million tokens. This is 80 tokens per second, running Llama 3, 8 billion parameter. A better alternative would be to run our Ampere instances. This is the A1 instances at Oracle. You could save 28%, achieve the same number of tokens per second as on an A10 card. So much cheaper. And then also, there's a huge power benefit. So as an end user, you might care about the carbon footprint, about your ESG goals. Well, this solution consumes 1/3 the power of the solution that involves an NVIDIA A10 card plus an Intel CPU. So much, much more efficient solution, much cheaper solution than running with GPUs. As Oracle rolls out the A2 instances, these results will continue to improve. Some of the benefits of the A2 instances with Oracle: twice the VM size as was available with A1, taking advantage of that large core count of Ampere 1. Increasing performance per VM, and incredibly higher performance per watt on our A2 instances with Oracle. So check it out at Oracle. I'm really excited to see that ramp. Now, I talked before about the need for broad solutions, having a very strong ecosystem out across the market. And I think that if you look back over the last couple of days, I think a lot of our competitors are saying the same thing. Maybe not all of them, but I think many of them believe that a walled garden around AI is not healthy for the industry. Everyone agrees that power is the biggest constraint to continued growth of AI, that denser rack-level solutions is what's important, and that legacy solutions are probably not the right fit, that we need other solutions in the market than what we've been using over the past decade or more. So that's why it's really important that it's not just Ampere that's building these new innovative solutions. It's about an ecosystem of other partners that are building specialized and extraordinarily innovative solutions around the AI space. So we created the AI Platform Alliance last October. We have a dozen announced members right now in the Alliance. And what we've been focusing on at the beginning is building best-in-class solutions to address various AI inferencing use cases. So we're bringing together various power-efficient solutions, bringing them into platform-level solutions, ensuring that there's an open and easy-to-use software model wrapped around it, and we've created some use case-specific software and hardware solutions. I'll tell you about one of them here in a minute, but that's not where it stops. Today, we're building at the platform, at the server level, but we've now kicked off a working group, an open silicon integration working group within the AI Platform Alliance. The goal here is to now use best-in-class optimized accelerators with an open standard like UCIe to create a way to more effectively, more quickly, create integrated chiplet-based solutions for various workloads. This will allow us to get to scale by using a common platform, using open interfaces, which are always good for the industry, and rapidly develop a range of solutions that can be more specialized for different use cases. So I'm really excited about what we're doing with the AI Platform Alliance, and I think that this is a really exciting way to build something that looks a lot different than a proprietary walled garden. And the first of those solutions that have been built out with the AI Platform Alliance is with NetInt. With NetInt, we've built out this Quadra video server featuring Ampere CPUs as well. NetInt has some extraordinarily efficient and high-performance video processing units. They're Quadra T1U units. This solution takes those VPUs, the Ampere Ultra family CPUs, and creates an extraordinarily efficient platform. This platform can transcode 360 streams. It can provide real-life translation for 40 channels simultaneously, all in an extraordinarily efficient solution. So this is an example where a specialized solution makes a lot of sense, because if you are a live streamer, if you're a broadcaster, this is your key workload. So you probably are running OpenAI's Whisper model, you're probably processing a lot of video. This is a great, easy-to-use solution that can be easily scaled across the market. So I'm really excited about this solution. This is the first of many that we'll see coming out of the AI Platform Alliance, really focused on different areas where you either want very specialized performance for a specific use case, or you're trying to push the limits of performance for big scale-out AI workloads. And an example of those types of workloads is what we've done with Qualcomm. So with Qualcomm, we have built out a joint solution. It features our Ampere CPUs and also the Qualcomm Cloud AI 100 Ultra accelerators. So we take the best of what each company has built, really efficient CPU that delivers a lot of high performance with a lot of cores, and then the Qualcomm Cloud AI 100 Ultra accelerator. And what this solution is able to do is run some of the industry's largest generative AI models. So running models that now go beyond the 7 to 8 billion parameter range, but out into the 100 billion parameter range and beyond. And the advantage of this joint platform is that we're able to together deliver multiple times, about 2x more performance at the rack level. So we can deliver about 2x times more inferences per second, or process 2 times more tokens per second with this solution than with a alternative solution, say using the Nvidia H100. And you can do that at over 5 times lower cost per inference. So extraordinarily more cost-effective, delivering over 2x the performance. And the solution today is available in a server from Supermicro. Today, it's based on the Ampere Ultra family servers from Supermicro, and then we'll ramp that out into the Ampere 1 family. So I'm really excited about the work that we've been doing with Qualcomm. It's the first of many things that you'll see from us together. And again, I think a really good example of the way that the industry needs to come together and build these types of joint solutions and build that incredibly vibrant ecosystem so that we can satisfy not just 1 or 2 use cases, but a wide variety of use cases across the market. So I want to thank everybody for attending here today. To recap, we are obviously in the midst of an extraordinarily challenging time, but one that presents an amazing opportunity for us to change the trajectory of what we're doing, to move from legacy technologies, to avoid getting siloed into vertical solutions, and instead build amazing partnerships, build big horizontal solutions, solutions that are easy to build, easy to scale, easy to deploy, solutions that look nothing like the ones of the past, that break free of the legacy constraints, that push the limits in terms of performance, in terms of efficiency, in terms of scalability. And there's no better time than now. So whether you're focused on AI applications right now or other applications, going in, refreshing your aging infrastructure, focusing on infrastructure that is more efficient, that's more cost-effective, is going to solve each of your problems. It will give you more budget, more power capacity for your AI challenges, and it will allow you to run your other workloads in a much more effective manner. So now is the time to make this shift, and to do so, again, supporting this broad ecosystem. At Ampere, we're committed to these broad industry solutions. We're committed to open source, and I'd like you to help join us on this mission to reinvent the data center and to foster in a new era of AI compute. So thank you.
Thank you, Mr. Vite, for your informative presentation. We will now take a short break. If you need to use the restroom, please exit from the F entrance on your right-hand side. The last session will begin at 4 p.m. Please return on time. Thank you for your cooperation.
So let's raise our voices in this digital symphony. Tech giants and startups rewriting history. In the pursuit of innovation, we stand tall. At COMPUTEX's embrace, where dreams enthrall. Spark, illuminate digital nights. Yes, yes, yes. Tech titan startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. AI ignites. Hey. Innovation spark, illuminate digital nights. Yes, yes, yes. Tech titan startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. Check it, it's the rise of the tech scene. Listen close, AI's the heartbeat. Tech giants, they impose startups on the grind. Chasing their dreams in the realm of innovation. Nothing's as it seems, networking sessions where minds collide. Ideas sparking innovation as our guide. From the product launch to thought leadership stance, we're carving our path, taking every change.
So let's raise our voices in this digital symphony. Tech giants and startups rewriting history. In the pursuit of innovation, we stand tall. At COMPUTEX's embrace, where dreams evolve.
Spark, illuminate digital nights. Yes, yes, yes. Tech titan startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. Check it, it's the rise of the tech scene. Listen close, AI's the heartbeat. Tech giants, they impose startups on the grind. Chasing their dreams in the realm of innovation. Nothing's as it seems, networking sessions where minds collide. Ideas sparking innovation as our guide. From the product launch to thought leadership stance, we're carving our path, taking every change.
So let's raise our voices in this digital symphony. Tech giants and startups rewriting history. In the pursuit of innovation, we stand tall. At COMPUTEX's embrace, where dreams evolve.
Spark, illuminate digital nights. Yes, yes, yes. Tech titan startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. AI ignites. Hey. Innovation spark, illuminate digital nights. Yes, yes, yes. Tech titan startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. Yo, check it, it's the rise of the tech scene. Listen close, AI's the heartbeat. Tech Tech giants, they impose startups on the grind. Chasing their dreams in the realm of innovation. Nothing's as it seems, networking sessions where minds collide. Ideas sparking innovation as our guide. From the product launch to thought leadership stance, we're carving our path, taking every change.
So let's raise our voices in this digital symphony. Tech giants and startups rewriting history. In the pursuit of innovation, we stand tall. At COMPUTEX embrace where dreams enthrall.
Innovation spark, illuminate digital nights. Yes, yes, yes. Tech titan startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. AI ignites. Innovation spark, illuminate digital nights. Yes, yes, yes. Tech titan startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. Yo, check it, it's the rise of the tech scene. Listen close, AI's the heartbeat. Tech giants, they impose startups on the grind. Chasing their dreams in the realm of innovation. Nothing's as it seems, networking sessions where minds collide. Ideas sparking innovation as our guide. From the product launch to thought leadership stance, we're carving our path, taking every change.
So let's raise our voices in this digital symphony. Tech giants and startups rewriting history. In the pursuit of innovation, we stand tall. At COMPUTEX embrace where dreams enthrall.
Spark, illuminate digital nights. Yes, yes, yes. Tech titan startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. AI ignites. Innovation spark, illuminate digital nights. Yes, yes, yes. Tech titan startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. Yo, check it, it's the rise of the tech scene. Listen close, AI's the heartbeat. Tech giants, they impose startups on the grind. Chasing their dreams in the realm of innovation. Nothing's as it seems, networking sessions where minds collide. Ideas sparking innovation as our guide. From the product launch to thought leadership stance, we're carving our path, taking every change.
So let's raise our voices in this digital symphony. Tech giants and startups rewriting history. In the pursuit of innovation, we stand tall. At COMPUTEX embrace where dreams evolve.
Spark, illuminate digital nights. Yes, yes, yes. Tech titans, startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. Innovation spark, illuminate digital nights. Yes, yes, yes. Tech titans, startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. Yo, check it, it's the rise of the tech scene. Listen close, AI's the heartbeat. Tech giants, they impose startups on the grind. Chasing their dreams in the realm of innovation. Nothing's as it seems, networking sessions where minds collide. Ideas sparking innovation as our guide. From the product launch to thought leadership stance, we're carving our path, taking every chance.
So let's raise our voices in this digital symphony. Tech giants and startups rewriting history. In the pursuit of innovation, we stand tall. At COMPUTEX embrace where dreams evolve.
Spark, illuminate digital nights. Yes, yes, yes. Tech titans, startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. Innovation spark, illuminate digital nights. Yes, yes, yes. Tech titans, startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. Yo, check it, it's the rise of the tech scene. Listen close, AI's the heartbeat. Tech giants, they impose startups on the grind. Chasing their dreams in the realm of innovation. Nothing's as it seems, networking sessions where minds collide. Ideas sparking innovation as our guide. From the product launch to thought leadership stance, we're carving our path, taking every chance.
So let's raise our voices in this digital symphony. Tech giants and startups rewriting history. In the pursuit of innovation, we stand tall. At COMPUTEX embrace where dreams evolve.
Innovation spark, illuminate digital nights. Yes, yes, yes. Tech titan startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. AI nights, hey. Innovation spark, illuminate digital nights. Yes, yes, yes. Tech titan startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. Yo, check it, it's the rise of the tech scene. Listen close, AI's the heartbeat. Tech giants, they impose startups on the grind. Chasing their dreams in the realm of innovation. Nothing's as it seems, networking sessions where minds collide. Ideas sparking innovation as our guide. From the product launch to thought leadership stance, we're carving our path, taking every change.
So let's raise our voices in this digital symphony. Tech giants and startups rewriting history. In the pursuit of innovation, we stand tall. At COMPUTEX's embrace, where dreams enthrall.
Spark, illuminate digital nights. Yes, yes, yes. Tech titan startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. AI nights, hey. Innovation spark, illuminate digital nights. Yes, yes, yes. Tech titan startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. Yo, check it, it's the rise of the tech scene. Listen close, AI's the heartbeat. Tech giants, they impose startups on the grind. Chasing their dreams in the realm of innovation. Nothing's as it seems, networking sessions where minds collide. Ideas sparking innovation as our guide. From the product launch to thought leadership stance, we're carving our path, taking every change.
So let's raise our voices in this digital symphony. Tech giants and startups rewriting history. In the pursuit of innovation, we stand tall. At COMPUTEX's embrace, where dreams enthrall.
Spark, illuminate digital heartbeat. Tech giants, they impose startups on the grind. Chasing their dreams in the realm of innovation. Nothing's as it seems, networking sessions where minds collide. Ideas sparking innovation as our guide. From the product launch to thought leadership stance, we're carving our path, taking every change.
So let's raise our voices in this digital symphony. Tech giants and startups rewriting history. In the pursuit of innovation, we stand tall. At COMPUTEX embrace where dreams enthrall.
Spark, illuminate digital nights. Yes, yes, yes. Tech titans, startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. Innovation spark, illuminate digital nights. Yes, yes, yes. Tech titans, startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. Yo, check it, it's the rise of the tech scene. Listen close, AI's the heartbeat. Tech giants, they impose startups on the grind. Chasing their dreams in the realm of innovation. Nothing's as it seems, networking sessions where minds collide. Ideas sparking innovation as our guide. From the product launch to thought leadership stance, we're carving our path, taking every change.
So let's raise our voices in this digital symphony. Tech giants and startups rewriting history. In the pursuit of innovation, we stand tall. At COMPUTEX embrace where dreams enthrall.
Spark, illuminate digital nights. Yes, yes, yes. Tech titans, startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. AI nights. Hey. Innovation spark, illuminate digital nights. Yes, yes, yes. Tech titans, startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. Yo, check it, it's the rise of the tech scene. Listen close, AI's the heartbeat. Tech giants, they impose startups on the grind. Chasing their dreams in the realm of innovation. Nothing's as it seems, networking sessions where minds collide. Ideas sparking innovation as our guide. From the product launch to thought leadership stance, we're carving our path, taking every change.
So let's raise our voices in this digital symphony. Tech giants and startups rewriting history. In the pursuit of innovation, we stand tall. At COMPUTEX is embrace where dreams enthrall.
Welcome back, ladies and gentlemen. Our last session today will be delivered by Mr. K.S. Phua, the CEO of Phison. He will enlighten us with his vision on the challenges and opportunities of generative AI applications. A warm welcome to Mr. Phua.
Good afternoon, ladies and gentlemen. 3 days ago, I was in the Johnson's speech. He ran. I know it because I have time. This is the last session, right? So I have enough time to introduce you about Phison's, our new invention. So thank you for participating in this section. I'm K.S. Phua, as a CEO from Phison. Today, I'd like to deliver you something very new about generative AI to you. So recently, everybody crazy about generative AI, especially crazy about Jensen Huang, right? You can see the news, night market everywhere. But that's good. That's helping Taiwan to build the whole AI system in the world. But something is good there, but something still may happen. So that's we discuss what is going potential to happen. I personally raise a question. Can this existing generative AI possible to be profitable and sustainable in midterm? Why I'm not talking short term? Because short term, everyone crazy, just spend money. You see the cloud, they keep burning their capital. They are not thinking about profit. But once all the equipment already, midterm, can this kind of a business able to generate the profit? If not, this can be a crisis. Today, I think they have a lot of experts here talking about generative AI. The cloud guy, they burn a lot of money. What I read from news, within a year, they spend like $50 billion to buy the GPU card from Nvidia, to install, consume huge of power, generate a lot of mature native model. What the data they get is from the public, from the open space, from the internet. They get the data to train the model. But is this model including the so-called sensitive data? So define what's the sensitive data. Your corporate, you have a lot of your own data. You are not allowed or you are not willing to put this data into the cloud, into the open space. That means they are not able to access to your data to get data to train into the model. So means all the native, the model from the cloud, what they can get is open space. Without the so-called sensitive data, can the users, like corporate users, your data is inside your hand without training by the model. You use the model for inference. They are not able to generate the data what you need. Means you have to put your sensitive data to detrain again. So what's the method to detrain the model good to fit to your own use? You have two methods. The first one, you can use a cloud service. Okay? Recently, they have a lot of cloud. They offer the service. They can come to you. They offer their service, their system. You put your data there, they train for you. But they have two challenges and two concerns. First, again, are you willing to share your data to them for training? After trained, who owns the knowledge? And second, after trained, you use a service as an inference, your budget potentially will be unpredictable or potentially can be unlimitable. Okay, so if you are not going to the cloud, then easier. You just buy equipment. But the equipment looks like it's not cheap. Okay, Phison, last year, my engineers came to me. They proposed to me that, okay, Phison is one of key designer in the world in the storage controller. We have 3,000 engineers. Actually, we are big. Okay, we are big. What my engineer proposed me, hey, Phison, we have to try to use generative AI for our future design to reduce our human resource and to improve our productivity. I said, good, good idea. So what can I do? They said, hey, boss, I need $2 million to buy equipment, DGX. My answer is simple. Hey, I no money. Go back. No budget. $2 million. I said, especially last year, right? Due to the economy, our business last year was very challenging. I said, hey, forget it. If 2 million NT, I can pay you now, but $2 million, forget. So this is what we are facing. I believe a lot of corporate CEO, corporate chairman, corporate president, you are facing the same challenge. You need to use the AI, but you may not able to pay that budget to train your sensitive data in your edge. Okay, so if they got no solutions, okay, then things may happen. Hey, I'm not saying the big word, okay? I'm just logically telling you, cloud spend money, create a model. Users want to use the model, but they need to fine-tune with their sensitive data, either cloud or either edge. Cloud concern, privacy, budget. Going to edge, no budget. If this is the case, the things may go to bubbles. I talked to many tier one, many big corporate CEOs. Most of them, they agree. I just had a meeting with my customers from US. I said, hey, are your company going to buy the equipment? They said, no way, too much. They may able to buy few set of a GPU system to fine-tune the small model or to doing some simple inference with a native model. But this is not helping them to improve their productivity. So if no solution, then I think most of you experienced the year 2000, right? What happened to year 2000? The world believed internet is going to be popular. So they invest a big money equipment into the so-called cloud. That time it's a cloud. Invest for 2.5 years, then realize the world, most of the area, they don't have an internet to access to the users. Then bubble. Until year 2004, internet start getting popular, access to the many users, then internet service start to ramp. And now cloud company, they are good. Everything is about users, how to access to the users. Only access to the users, then you can create the business model with profit. Then your business can able to sustain. Okay, generative AI, now possible, okay, facing the same challenge. So the solution to make the generative AI go popular and go sustainable is somebody have to deliver affordable in edge fine-tuning equipment. So what's affordable? Okay, today we are using the Llama 270B for fine-tuning. We need a lot of three sets of DGX, cost $1.5 million. That's a lot. If I can get the equipment, $40,000. $40,000 can use for fine-tuning and also can use for inference, $40,000. My budget is $40,000 with the power electricity fee. To me, this is affordable. So Phison, we deliver, we call adaptive. Okay? I give one more example. Actually, it's 25 years ago. Imagine 25 years ago, if you start your company, a lot of companies, they don't have their own server. The email address, somebody use Hynix, somebody use Gmail, somebody use Yahoo. In China, they use QQ.com. It's free to use. But all your email data, you store in the cloud. Why? Because you got no choice. You got no budget to buy your equipment. But today, every small individual company, you can easily buy a affordable server to build the mail server in your place, in your office, in your home. Your data keep in your place. So this is example. So we go to 25 years ago, there was a mail server. Like today's cloud AI service. Okay? Sooner or later, if we are able to deliver affordable edge AI computing, then can go to this side as a mail server. Then everybody, you can access to generative AI. And this is on-prem, will be safe, will be under your control. And very important, the total budget is limited. Equipment cost is there. What the rest is a power electricity fee. Okay, so this is today's I want to deliver to everyone that if this is going to happen, then the business can go sustainable. The other question is, how about cloud able to go to the users? Can you prove how to make a profit? Hey, cloud guys, they are smart. They are very smart. Okay, they know how to make money. But condition is you are able to access. So I give example, you do to the Google. Google developed the Android OS. They encourage a lot of companies, mainly in Taiwan and China, smartphone, IoT, OTT, a TV, a lot of things happening with the Android. Then Google, they're able to access to the users. Then they create their profit model. Same in the generative AI. Cloud, they create the model. The model able to go to the edge. The users can train on-prem. Cloud guy can access to the users, generate the business model. Then the Gen AI is going to popular. Cloud guy able to keep investing. Okay, this is helping the world to get the AI popular immediately. So this is the things we want to deliver. So what is the key point? Key point is users. You have to go to the users. But 99.9 users, they may not able to pay for that high cost of the systems. What today is talking about Gen AI is a few $1 million, few $10 million. I just found now they have one equipment from Nvidia is a $30 million. This is not our business, okay? So key point is we need to have users. Okay. Last, this is the things about affordable to edge fine-tuning equipment. So Phison, we're happy in COMPUTEX announced Adaptive Plus. This equipment can be workstation, can be server, doing fine-tuning and inference. So you get the equipment put in your company, may not need server room because the equipment is a less power consumption. You don't need to put air condition, okay? Room temperature is good. You get equipment in your site, you can train by yourself, you can inference by yourself, and data keep in your site is fully secure and you cover your privacy. So these products already, we did a lot of POC. We have a demo in the COMPUTEX whole one. So if happy, you're interested, you can go to it, take a look. This one is going to be popular very, very soon. So let me explain you what we are doing, okay? Look to this picture. I think today everyone knowing about H100. You know B200, maybe coming will be C200, I don't know, okay? Just joke, okay? So what's that? There's a GPU with the HBM. I think you know GPU, you know HBM. HBM is a high bandwidth memory, but cost is very high. So what Phison, our new invention, our innovative is, we put the storage into the system to reduce the HBM size. Indirectly, we made the total equipment cost go to low and affordable by the users. So this is what we are doing. And this is not just only the hardware, but Phison also will deliver few software design to our users. So first, I'd like to introduce about adaptive link. This is a middleware designed by Phison to optimize the management to our storage. This storage we name is adaptive cache. It's a high bandwidth, high performance, high endurance, but need to manage by our adaptive link. Okay, and this middleware, we are service to all our users. And we keep improving our version. The first version was 1.0, the second version is coming. Will improve performance and reduce more DRAM size in the system. More DRAM size reduced means more cost reducing. Then the equipment is more affordable by more people. The storage side, we call it adaptive cache. Again, this is not SSD, okay? This is not typical SSD. This is a high endurance, high performance, high efficiency cache, which able to reduce the big portion of HBM. And this is a Phison proprietary design. We service customer with our adaptive link bundle with our storage, our cache system, with our ecosystem partner. We also release the free software, Adaptive Pro Suite. Like, I give you one example. Many years ago, when I was a student, the computer is using DOS. DOS is hard to use. You need to debugging this, debugging that, right? Only engineers know how to use DOS. Like today, only engineers know how to use AI training. But when Windows coming, the kindergarten kid, they can easily to learn how to use a PC within 30 minutes. Phison Adaptive Pro Suite, this is a proprietary design by Phison. It's a Windows-based, which helping you to easily load the data into the computer system for fine-tuning, doing the inference, and help you to monitor the system's efficiency and also the resources. And this software will release by free. And we also deliver the whole SDK to our partners. You can modify the user interface. You can customize what you need in your territory. So with the full turnkey, full solution from Phison, middleware, the storage, cache, and their system software for user interface, users, system integrator, you can easily take this, helping your customers faster adapt to use generative AI on-prem in your home, in your office. And this will helping everyone able to access the generative AI with very low affordable cost. Today, what you can use is only ChatGPT. Give example, you ask one question to ChatGPT 10 times, the 10 answer will be slightly different. This can use for school homework, okay? Professor don't care. But this cannot use for business. Business, we need accuracy. Accuracy, you need to train by your own data. So with this equipment, everyone can easily go to touch the generative AI to improve your productivity. Like 25 years ago, your email is in the cloud, but today, email is in your site. So this is a difference. This is a Phison invention, try to help everyone to use the AI immediately. So this is very new concept, very new concept. I still remember, I'm watching the YouTube which Jensen interview by, if I'm wrong, it will be like CNBC. Jensen saying that his goal is you own your own data. You own your own AI. You train your own data. But he may forget, we are not that rich to buy equipment. But with our adaptive solutions, most corporate individual, you need the generative AI, you can easily own your data, train your own AI, you own your own training in your site. Okay, so this will help the cloud. They are connected to the edge. So in these 6 months, by the way, this is very new concept. When my engineers told me, hey, boss, I can take SSD to replace HBM, I said, I don't believe. He showed me, I still don't believe because I don't know what he's doing about. So I said, hey, this we go to the Jiao Tong University, go to the professor, then the professor try. So professor taking our solution, they try their training with the LLM. Hey, quite successful. They're surprised. I was so surprised. Then I smell the business, okay? I think this is good to use. So Phison start to invite our hardware partner, our system partner, system integrator, software partner to build an ecosystem to help deliver this to the users. So we already have over 100 plus of a use case, which is already used in the market. Like Phison internally, now we have a 12 use case. We train Llama 2 model to help engineers doing firmware design. We train the model to help engineers to convert the C code to the document. We train the Llama 2 model in-house for our knowledge management. Now we have planned to train a lot of systems to help improve productivity and make the things more efficiency. We are ongoing. So more than 100 plus cases already success to use trained by this equipment. So this is a good to use. So now is the time we have to deliver to the world, to tell the world, now you are able to access to their AI with low cost. So this is currently our ecosystem partner. We are located in Taiwan. We start to build ecosystem basically in Taiwan. Basically in the world now, only Taiwan company know how to using these things, okay? But if the world, you need everything, our Taiwanese partner can help you. So we have many hardware partner. We have a system integration partner. We need a more software partner to improve the use case, to solve the user's requirement. So this already happened. So welcome, you go to the whole 4th floor, you can come to Phison, but recently too crowded, okay? Too crowded, okay? It's long queue there. So next year, we will have a big booth, okay? To welcome everyone from you to visit us. But today, with the COMPUTEX, I want to deliver this message to everyone. If you are on the live, you are from the other side, from other country, listen to me. We have a good solution to help your territory, to help a country to use AI immediately. And every government, especially third world country, the government keeps saying, hey, I need my citizen to know how to use the AI, but we don't have a budget to invest. Okay, now is the time. We are ready. Let's come to Taiwan. We have a total solution. We can deliver you the total solution. You bring to your place. You can use solution also to train your new startup partner, new startup company to develop the software application on top of these solutions to help create the job, to help create the business, and in the end create your GDP. And this is ready. So I have 30 minutes. I will be taking on timer, so don't be sleepy, okay? Very important. The key takeaway, let me summarize, okay? If you want to use a generative AI, you will go to the cloud. Privacy, the cost. The budget is not limited, okay? At the end, you have to pay the permanent subscription fee. Then the long-term cost is there. I'm using a word maybe difficult, but little bit bad. It's like kidnapping. You will be kidnapped forever, okay? So go to the edge with the solutions. Bring the products to your country. Build your own ecosystem. Create a job for your citizens. Create the economy in your place. If you're good, you can export. So come to Taiwan. We are willing, we are happy to help you to bring your citizen to use AI immediately. So go to the edge. The cost is predictable. The risk is almost nothing because there's no need to access to internet. So don't worry about ransomware. Don't worry about hacker. then you can manage data in your site. Okay, so this is the things we can deliver in this COMPUTEX. So this is my great honor in the closed section to deliver something very new to you. So everybody keeps saying Taiwan is a center of AI. You're right, but it's a manufacturing. But this adaptive is an invention from Taiwan. It's a whole application platform from Taiwan, able to help the world, the population, to go to the AI immediately. So this is a partner we are working with. It's a hardware partner, so we have most of the Taiwan major brand, the ODM partners. Okay, the last. My people ask me to say this is so-called democratic AI. I say a little bit sensitive, but it's okay. Everyone able to access to AI, no matter you rich, you are not that much rich, you can use AI immediately with our adaptive solutions. So last, we have the QR code here. This side, you go there, you can have some inquiry. We have some samples. If you are a developer, you can contact us. We have samples you can start to use to see what's that. In this side is a booth, our location in the Hall 1 COMPUTEX. We are welcome you to come to see. This is a real, this is not magic. Okay, and I believe in few months, because this is mature, hardware is mature, software is mature, within few months, this is going to deploy in many sites. So, ladies and gentlemen, this is a things very new in COMPUTEX, and we are happy to be here, and we are glad to work with you. So if you're interested, please contact us. We are going to bring our ecosystem to you that you can connect together to bring this innovative AI go to your country. Then help your country, your people can improve the AI technology to improve the productivity of your economy. So thank you so much.
Thank you, Mr. Park, for your insightful vision. And that concludes the 2024 COMPUTEX Forum themed Let's Talk Generative AI. We hope you've all gained valuable insights and inspiration from today's forum. Take these learnings home and share them with your colleagues and partners. While the 2024 COMPUTEX Forum has come to a close, the conversation about generative AI continues. Thank you for joining us. Please watch your step as you leave. See you next year.
Yes. Tech titans, startups, forge your paths ahead.